An Introduction to the Magnetic Resonance Amplifier. By Joel McLean and Norman Wooten. With low-level ultrasonic input signals, the magnetic resonance amplifier, MRA, produces usable direct current power at levels above unity. This circuit is based upon the work and theories of John Ernst Worrell Keely, and is offered into the public domain in his memory. Introduction. Without lengthy discussion about the ether, tetrahedral geometric aggregate resonance or the rule of nines, it is possible to understand this circuit as basically a tuned magnetic and quartz amplifier. However, it was necessary to study those subjects in order to design and build the MRA, so if you want to fully realize how it works, avail yourself of the files on KeelyNet which contain all of that and much more. In the MRA schematic below, there is a tunable low-power oscillator which supplies a signal to one side of a barium titanate transducer. The opposite side of the transducer is connected to a primary coil which is wrapped around a barium ferrite magnet core. The opposite end of the primary goes back to the oscillator. A secondary is wrapped around the primary and is connected to an ordinary bridge rectifier, and the output of the bridge is applied to a DC load. A filter capacitor can be used on the output of the bridge, and was used on the MRA which we built. Additionally, a load resistor across the capacitor will keep the output DC from getting too high as the circuit is tuned. We found that a 30 ohm, 10 watt resistor was sufficient. Once this has been assembled, put a voltmeter across the output resistor to monitor the voltage rise as the circuit is tuned. Adjust the oscillator frequency to provide the highest DC output. During this process, be aware that the voltages across the piezo and the coil will be very much higher than the signal level which you are applying. We have seen combined voltages of almost 1000 volts AC with only 30 volts AC of signal input. When the circuit is tuned, the magnet will be singing at around 8000 to 11000 Hz. If the piezo sings, you are exceeding its power capabilities and will need to reduce the number of turns on your primary. The frequency that resonates both the piezo and the magnet at optimum resonance will be 3 times, 3 octaves above, the frequency at which the magnet is singing. This is the 9 harmonics that are mentioned in the rule of nines. To test the circuit, place a precision, high wattage, low ohm resistor in series with the output from the oscillator to the piezo, and measure the voltage drop. It should be very small, less than 0.1 volt AC. Use this value to determine current in the series circuit, and then calculate power. Next, measure the DC voltage across your output load resistor, and once again calculate power. You should be between 3 to 4 times above the previously calculated input power. Once the circuit is in operation, you will note that the voltage will vary by 0.1 volt DC or more, depending upon the time of day. This is due to the nature of etheric forces inherent in the Earth's magnetic field. Watch for peak voltage at or before sunrise. In our circuit, we measured 0.084 volt AC drop across a 2 ohm series resistor, for a total of 0.685 watts dissipation in the primary. With this, we attained 2.75 watts of output power and used this to drive a lamp and a motor. Increasing the signal voltage had the effect of decreasing the primary current while boosting output power, thus improving the power gain ratio. We believe that larger power systems can be built by using larger coils, more piezos, and a lower frequency, as long as the aggregate combination is within the resonant frequency range of the components. The MRA is essentially a means of releasing the electrical energy stored in magnets. As such, it is an AC battery with DC output. It can be used for a portable, self-charging power supply with a solid-state oscillator and rechargeable battery. For those who want a synopsis of the technology, the following paragraphs are offered, but it is strongly suggested that you follow up this reading with a more thorough study of the KeelyNet files. Matter equal energy. To change matter, change the energy. Creation of a magnet is achieved by a process which causes the matter to be both expanded and compressed at the same time, with the result that a magnet is in a constant state of collapse. This is why magnets attract material with similar lattice structures, as they attempt to fill the energy void which created them. The domains of the magnet are fixed after the process of magnetization, and the only way to extract electrical energy is to physically spin a coil relative to a magnet. However, it is also possible to induce virtual rotation by applying the resonant frequency of the magnet, which causes the lattices and the domains to vibrate. However, the power required to do this is greater than the energy released by the virtual rotation. Therefore, it is necessary to increase the vibration without using excessive current. The piezo has a virtually inexhaustible supply of free electrons, and it releases them when it is stressed. Using the piezo in series with the primary coil will almost eliminate primary current, because it is voltage which stresses the piezo, not current. Therefore, the piezo can be stressed with very little actual power, and provide the current to the primary coil which vibrates the domains of the magnet. The piezo is the catalyst for the circulating current with the primary coil. The circulating current is additive, and this is the reason for the high potentials developed across both the piezo and the primary coil. It is at this point that resonance becomes important. You must have 3 octaves of separation between the magnet resonant frequency and the signal supplied to the piezo. The circulating current is rich in harmonics, and this is necessary for the operation of the circuit. Although the circuit is simple, it utilizes the concepts of phi, of virtual rotation, of tetrahedral geometry, piezo and transformer theory, and electrical knowledge. It is not suggested as a beginner project, because of the high voltages present. For engineers and technicians of experience, it may be difficult to accept that the MRA is above unity. The ramifications are enormous. Hopefully, it will help to build a better world. The Magnetic Resonance Amplifier, Description of Operation. By Joel McLean. The MRA is a series resonant LC circuit in which power gain is attainable as a result of the increase in effective impedance under certain operating conditions. When the series impedance increases, primary current is reduced. When the power available from the secondary coil either remains the same or increases as the primary circuit impedance increases, a power gain occurs. This is not possible with a series resonant circuit made of conventional materials. Even unity power transfer is considered to be unattainable as a result of accumulated losses in the components, which are passive, reactive devices. Materials and construction methods are chosen for these components based upon the type of application and frequency to be applied, with the goal of minimizing losses. A typical capacitor with polyethylene dielectric has a dielectric constant of 2.3 times that of air. Air has a constant of 1.0, and is the basis for comparison. Titanium dioxide, however, has a dielectric constant maximum of 170, and a corresponding power factor of only 0.0006, comparable with polyethylene, so that the dissipation of primary current in the dielectric is extremely low. This is where the comparison ends, because the titanium composite capacitor is also a piezoelectric device as well as an excellent capacitor. Heat adversely affects the power factor of most dielectric materials. Titanium zirconate, however, contains polar molecules which rotate as thermal pressure is applied. This rotation increases the dielectric constant if the frequency applied is equal to or lower than the resonant frequency of the dielectric. At series resonance, the rotation of polar molecules contributes to heat. As the dielectric constant increases, a corresponding release of free electrons occurs, as a direct result of the piezoelectric properties of the device. In application, the MRA is tuned at resonance for maximum power transfer, then detuned slightly for maximum power gain. This relates directly to the use of thermal pressure at resonance, and the effect that this has on continued polar rotation and the release of donor electrons. The coil, or primary of the MRA is a magnetic core which, relative to the fixed capacitance of the piezo, is a tuned permeability device. This is often used in RF devices to attain a stable resonant frequency. Magnetic materials are chosen based upon the operating characteristics of the intended application to reduce eddy currents in the operating range. In these applications, the resonant frequency of the magnet itself is avoided, as this would beat with the oscillating current. However, in the MRA, this is the exact effect which we want. The barium ferrite magnet resonates audibly at frequencies which are harmonics of the series resonant frequency. The effect of this in a typical audio application is called harmonic distortion, and is not desirable, but once again, in the MRA, this is what we want to occur. There is energy in the harmonics, and this energy serves to both counter eddy losses as well as to oppose primary current flow, while contributing to circulating current within the resonance circuit. The net effect of this is that when the MRA is detuned, harmonics of the audible frequency beat with primary current, opposing its flow, while the increase in circulating current couples more power to the secondary, and therefore to the load. This is how the power gain is attained, basically by considering the naturally occurring harmonics as beneficial instead of as undesirable effects to be filtered out. When the MRA is detuned, the effective impedance increases as seen by the source, while the power available to the load decreases in less proportion. This is measurable by using resistive equivalent circuit testing. However, the detuning is load dependent, and slight adjustments are required if the load requirement is greater than the power band of a harmonic interaction. After retuning, the power to the load will increase in quantum intervals as the circulating current is reinforced by the reaction of the permeable magnet core. This will be seen as slight incremental voltage increases across the load device. Once the magnet is ringing, its frequency and therefore harmonics remain stable, as long as the series resonant range is not exceeded. Therefore, the detuning affects the piezo only, and the circulating current increase is a result of the phase relationship between the harmonic and the source. Voltage amplification is seen across the primary, measurably higher than the source voltage, and this is seen by the secondary. This is not the same thing as a power gain, because the power gain is a direct result of effective impedance. It should also be noted that the term virtual rotation has been applied in describing the operation of the MRA. The comparison is made with a generator, in which relative motion occurs between a coil and magnet. Rather than use physical energy to rotate a mass, the MRA uses resonance to rotate the energy. This is seen in the polar rotation of the piezo dielectric as well as in the molecular energy occurring in the reactive component of the magnet, i.e., the ringing. The lattice structures of the piezo and magnet are compatible for virtual rotation, and the materials complement each other electrically. In the past, researchers have noted many effects which occur at aggregate resonance, which typically includes a range of 3 octaves. Anomalous energy gains were referred to as etheric. The ether was believed to exist outside of the 3 physical dimensions, and could be tapped for free energy at resonance. Etheric energy is said to be limitless, but to vary locally with increases in Earth magnetic fields at sunset and sunrise, like the tides of an infinite ocean. This effect is not thoroughly understood, but has been observed in the MRA, as increases in output in the early morning, and decreases in the early evening. This is still being studied. Experimentation will determine the optimum MRA design for a specific range of applications. Vanguard note: the use of Lenz's law, back EMF, is legend in free energy circuits. When the back EMF is reversed and phase matched to the forward EMF, you have an increase in efficiency because of the reduction of eddy current heating through the addition of the previously wasted power. This is generally understood to apply primarily to magnetic flux, yet because frequency is involved, phase conjugate principles play a major part. Phase conjugation applies to all frequencies regardless of the type of energy being used. Harmony, constructive interference, and dissonance, destructive interference, are controlled using phasing and frequency relationships. If the rhythmic energy flowing through the mass is made resonant to the mass aggregate resonance, you further reduce the resistance and impedance, thereby achieving unity and in some cases over unity. Most people want clean and simple circuits. These would not entail physical motion or large inductive masses as are encountered in orthodox generators. The MRA circuit fits this approach very nicely because it does not involve moving mass, but rather moving energy harmoniously to produce energy. Further information on the MRA, its operational characteristics, correlations and updates will be provided as they are documented. New ZPE breakthrough, magnetic resonance amplifier. By Joel McLean and Norman Wooten. Please note, this is a preliminary report that will be followed by updates with more detail. Future versions will include various measurements of the components used in the circuit that is currently running. From all appearances at this date, the circuit components will simply give varying outputs and do not appear to be all that critical. It was felt that this information should be released to the public as rapidly as possible, rather than risk loss of the information or the demo by circumstances beyond our control. There have been too many discoveries which have disappeared by not being openly shared. We would rather risk being flamed by other experimenters who actually build the circuit than take the chance of the information being lost by keeping it within a select group. Our two primary fears are that someone will attempt to patent what is intended to be a gift to humanity, possibly with an intent to profit from others' work or to lock it away, the other that it might be suppressed in some other fashion. Therefore, the widest possible distribution is requested, and duplication attempted wherever possible. At the time of this correction to the original file, we have confirmation as to the numbers and others are working on the circuit on their own. Please take this information in the spirit of how it is given, as a gift to humanity. The inventors are Joel McLean and Norman Wooten. You can contact them via KeelyNet or directly. The circuit is being tested at various levels and attempts at duplication are underway. At this point, there is only one circuit. We will openly post other successful duplications or failures. Please feel free to try it yourself. The cost is minimal. One other point, the crystal transducer was thought to be barium titanate and there is reason to believe it is in fact titanium zirconate. These are disc-shaped, about 3 in diameter with a 1 diameter hole in the center. The disc is about 3/8 thick and is coated with silver on both sides. Thank you for your open-mindedness. They are advertised in the back of many electronics magazines for about $5 each. We have access to a small stock and might offer them for experiments should people ask for them. Good luck, and seize the day. Vanguard note. This device incorporates power multiplication principles using multiple resonances as claimed by Keely and Hendershot. It also corresponds in some ways with Floyd Sweet's VTA and Joe Parr's energy spheres from pyramids. Joel called Sunday night in an excited state. He and Norman took turns explaining what they had achieved using this circuit. The power input measurements were about 600 milliwatts and yet the circuit was generating about 2.5 watts on the output. Norman hooked up a DC motor and he said it was spinning like crazy in addition to a light bulb glowing brightly. Norman was laughing and said they'd beat Harold Puthoff's 1 watt challenge as issued at the 1994 ISNE conference in Denver. This has created quite a bit of excitement and Puthoff now has a faxed copy of the circuit. No doubt it will be everywhere in a very short time. The hope by Joel and Norman is that others will duplicate the initial effect and be able to expand on it to derive useful power. Sweet claimed something on the order of 1.3000000 over unity. The input power to his device was 10 volts alternating current at 29 ohms, 290 milliwatts. The output had been loaded to as high as 3000 watts. The initial MRA circuit is something on the order of 1.5 and is believed to be scalable. Joel says the coil he had wound around the barium ferrite magnet was not in the least precision and he is of the mind that a huge coil surrounding the magnet will produce a proportional increase in power. Early talks with various KeelyNetters about the Sweet circuit led many of us to believe that barium, when excited, rings for a long time when the exciter is removed. At the ISNE conference, Don Watson confirmed this with his analogy of glowing luciferase as found in fireflies or other phosphorescent materials. A weak stimulation continues to produce light for a time after the stimulation is removed. So, here is a wonderful opportunity to build a pioneering device. If you have questions or suggestions, you may direct them to Joel McLean or Norman Wooten at KeelyNet. I think they both need to be commended for their willingness to share what many would keep proprietary or die with the secret. Ferroelectric capacitors and the magnetic resonance amplifier. By Tom Bearden. In a nonlinear ferroelectric capacitor there are three major nonlinear processes involved, so it is possible to carefully choose and arrange conditions so that the current through the capacitor moves against the voltage across its terminals. With adroit switching and timing, and some consideration for resonance effects, it is in theory possible to use such highly nonlinear effects in a circuit to allow, 1. An overpotential at the terminals of the battery as a reaction from the ferroelectric capacitor, 2. Consequent recharging of the battery via that back potential on the battery side, while the load is also being powered, 3. Consequent driving of the load on the load side of the terminals, and 4. Having a bypass ferroelectric capacitor across the terminals of the battery, where the capacitor is in the current against the voltage condition. McLean and Wooten patented a great little MRA, magnetic resonance amplifier, system, based on that application. Dr. Robert Bass, a very fine electrodynamicist of exceptional knowledge, experience, and ability wrote the patent for them, and assisted in their work. For that he was persecuted, unjustly attacked, and suffered financial difficulties. The system does not forgive highly qualified scientists who take a serious interest in perpetual motion machines, as permissible Maxwellian open dissipative systems are erroneously and derogatorily labeled by the orthodox scientific community. Any scientist violating that inquisition suffers the consequences. After technical discussions back and forth, the Patent Office even notified Wooten and McLean that the patent had been accepted and the patent would be issued. Within days, to their consternation, the patent was rejected, and that was the end of that. In other words, the fix was in our own experience in obtaining proper ferroelectric capacitors. Here's an interesting little tidbit, for what it's worth. We here at CTEC had included a specific use of ferroelectric capacitors, FECs, in one of our own patent applications. We attempted to obtain an FEC on the open market, one with the publicized nearly square S-curve of hysteresis. No capacitor manufacturer we contacted had one for sale. I went all the way to a Swedish company, was assured they made just what I needed, and purchased several from them to be shipped by airmail. In due time they arrived. They did not have the square S-curve at all, but were carefully layered to eliminate that S-curve, into a rather straight slanting curve. That kind of curve is absolutely useless for over-unity applications. Now why would anyone wish to purchase a supposedly nonlinear capacitor for its very nonlinearity, and instead purchase one that has been altered to behave just as linearly as possible? Why would a company advertise such a nonlinear capacitor, then sell you one that is highly linearized? And considering the rather substantial literature on nonlinear capacitors with square S-curves, why do not the capacitor companies sell such? We eventually found there is indeed a US manufacturer of ferroelectric capacitors with precisely that S-curve hysteresis loop. There was just one little problem. They had an agreement with the US Navy for all their production of those capacitors, and in that agreement they were not to sell any to private persons or companies. Now why would the US Navy wish to restrict a perfectly unclassified, open component from being sold on the open commercial market? Zounds. If one were a conspiracy buff, one might even try to connect this with the US Navy's long suppression of the Krone negative resistor. Do you suppose there could actually be some kind of connection between the two? Why, of course not. Paranoia and all that, you know. And still one wonders. The literature continues to publish tests of just such ferroelectric capacitors, etc. Contacting several of the researchers who author those papers, we found that they, at least the ones contacted, were all making their own ferroelectric capacitors if they wished one with that square S-curve. No one seemed to know where we could just purchase one off the shelf. Maybe all that is just coincidence. And maybe not. A possible interpretation. What the square S-curve hysteresis loop means is that, in one region of operation, with only a very tiny voltage change, you can get a rather enormous current change from that capacitor. In another region of operation, you can get a very large voltage change from the capacitor for a very small current change. In other words, biased into one region, you have essentially a voltage device. In the other region, you have essentially a current device. Neither device will cost you very much energy to operate it in its region. However, if you then nonlinearly mix the two outputs just right, as we filed on methods of doing, then bingo. You had a mixer device whose output now had both large current and large power, but you paid for an input not nearly so much energy dissipation. Remember, engineers calculate energy dissipation flow, never energy transport flow, to the mixer as what would be output by the mixer. The whole question is this. We all know about ordinary nonlinear mixing and mixers. We know that two signals can indeed be mixed nonlinearly. Can we build a nonlinear mixer and a dual circuit, where we feed a voltage-like signal in and also a current-like signal into the mixer, get the two combined into a high voltage, high current signal output, and do that without backfield coupling onto the two input signals to force equal energy dissipation in the input? Look at this very carefully. There is absolutely no conservation of energy law that requires that the energy input circuit dissipate as much energy as does the load circuit that receives the energy to power it. So why are we taught only those mixing circuits that will indeed force equal input dissipation? We need three things in the input: 1. Lots of voltage, 2. Lots of current, and 3. Small energy dissipation. That means we need a voltage-like input and a current-like input, which do not interact with each other on the input side of the mixer. We then need a mixer that will mix the two into a single signal with high voltage and high current, but will not back-couple its fields onto the input circuit to up the input dissipation. Is all this mystery in trying to obtain square S-curve ferroelectric capacitors really due to the fact that it is possible to use them together with other circuit components to produce such an over-unity mixer? Could something like that be behind what happened to McLean and Wooten, and to Dr. Bass? Again, at this point we wonder. So you think such odd mixing violates the conservation of energy law? Then think again. There is no valid law of physics anywhere, in complete contradiction to the assumptions in most electrical texts, that you have to conserve work. Energy, yes. Work, no. The energy that a circuit captures can involve the voltage only. Remember, W equal FQ. To get lots of W, joules, collected for use to power loads, we need lots of V, that is, dF, and lots of Q. We then need them mixed, interacting together. That's it. Anything else is what the circuit we construct is doing to fight us back. So, it would seem that we should focus on reducing the ability of that circuit to fight us back, while still doing the voltage amperage mixing and interaction thing. Even in the flawed old electrodynamics, 1 volt is 1 joule collected per coulomb of charge collector. So if you place 1 volt on a circuit which has few Drude electrons for collection, you get very little collected energy in that circuit, and note that the energy dissipated in that circuit can only be the energy that it first intercepts and collects. And if you then input the same voltage to a circuit with lots of Drude electrons, this second circuit will collect, and can then dissipate, lots of joules of collected energy. When you change the voltage of a circuit, you change the potential energy available for collection and dissipation. How much it collects and dissipates, then depends upon how many collectors it has to do so, and the dissipators it has to change the form of the collected energy. So one trick would appear to be to feed a nonlinear mixing unit from two circuits, one optimized for voltage and starved for current, and the second starved for voltage and optimized for current. The one remaining trick is to prevent any backfield coupling from the output of the mixer back to the two feed circuits. If you accomplish that, you have yourself a nice little over-unity device, perfectly permissible by the laws of physics and thermodynamics, and one which does not violate conservation of energy. It darn sure violates conservation of work, however. For that matter, so does a windmill or a water wheel, or a solar cell. You yourself do not have to perform work on something to get it to collect energy, asymmetrically regauge. It can collect the energy freely, if you arrange it correctly. Something else, such as a free flow of energy from the environment, is perfectly capable of doing that work on the intercepting collector, so that collection of energy in the circuit occurs. In my view, McLean and Wooten were accomplishing something very similar to our notion of nonlinearly mixing a low-power high-voltage input and a low-power high-current input, but using ferroelectric nonlinear resonance as the magic mixer to combine cheap high voltage with cheap high current and obtain the product of the two while only paying for their sum, so to speak. Think about it. But if you wish to pursue that approach to over-unity, let me advise you to first do your homework on nonlinear resonance, as opposed to the linear resonance in almost all the normal textbooks. It's not at all just a capacitance inductance resistance business or just simple LC resonance. LC resonance alone has never added a single excess joule of energy to the power system. The Rule of Nines, Resonant Geometry and the 0 Point by Joel McLean. Nest two tetrahedrons and you have the keys to the universe. The word rule has several different meanings, as a form of law, or as a form of dominion, or as a measuring standard. This text uses the word in all three contexts to define the effect of the supreme chord, the trinity of harmony, in the universe. In the late 19th and early 20th centuries, independent researchers began to notice the anomalous effects of applying resonance to a controlled experiment. Then, as now, this area of science is far from the mainstream. The results of those early experiments, such as the lightning of Tesla and the motors of Keeley, have been ignored both as science and as history, at least in America. Elsewhere, the work of Tesla is revered and has been amplified by paid research. With the creation of the magnetic resonance amplifier, or MRA, perhaps history and science will have to take a second look. The theories behind the MRA are the same as those of Tesla, Keeley, Russell, Bearden, King and others. The application, however, in a closed-loop ZPE device, takes a sharp turn away from effect and into application. Look at either a piece of quartz or a magnet, and you are looking at trapped energy. Tap the quartz, and you will get a spark as the electrical potential of the quartz instantaneously jumps. Spin a magnet relative to a coil of wire, and electrical current flows in the wire. How do we extract the power of these materials without the attendant physical energy required to either tap or spin them? Matter equal energy. To convert matter to energy, resonate the matter. To achieve energy output which is above the energy applied at resonance, use 3 octaves, and there will be 3 harmonious notes in each octave, for a total of 9 resonant frequencies. These notes occur naturally when the base frequency applied is 3 octaves above the magnet's resonant frequency, and equal to the resonance of the quartz. In this way, the potential applied to the quartz taps it, without the need to use physical force. The result is electrical output. Connect this output to a coil around a magnet, and the domains of the magnet, which comprise a tiny portion of its weight, and which do all of the work in a generator, will be forced to spin. This spin is called virtual rotation, because it is the spin of energy without the spin of the matter. However, this is only one application. How can we be sure that the rule applies anywhere else, much less universally? We have to go very far back in history to find the answer to this question. It involves phi, the universal constant, and delves deeply into the construction of Earth's great tetrahedrons. Nest 2 tetrahedrons, and put them in an orb, and you have a miniature model of the Earth's magnetic field. Where the bases of the tets touch the orb, you have the latitudes where all of the ancient pyramids were built. The top and bottom points are the north and south poles. This shows the naturally occurring magnetic resonance of Earth as an orb in rotation. Connect lines between the points, and you have a map of the ley lines, which were mapped very accurately thousands of years ago. Models of the Earth as described above have been found in the ruins of every civilization which built pyramids. Earth is, as it must be, a model of the natural harmonic relationship which exists at every level, from the universe itself to the subatomic. The relationships have been understood for a long, long time. This knowledge, and the use of the energy which it can be used to provide, was believed to be the curriculum of mystery schools in Egypt and Greece. If you look at the lattice geometry of silicon or germanium, you will find tetrahedrons. In his famous ring, Hans Nieper allowed the silicon of transistors to achieve self-resonance, with the result that the circuit became lower in weight. This implies that resonance may also be the key to countering the effects of gravity, or rather, the effect called gravity, for gravity is an effect, not a force. Gravity is suspended when you cancel the spin of the energy which comprises matter by resonating the matter. By virtually rotating the lattices, the subatomic particle spin virtually stops, like a spinning object seen with a synchronized strobe light. Because gravity is a complex quadrupole effect, when you stop the spin, you lose the effect. The matter which comprises the quartz and the magnet of the MRA is comprised of cube lattices, each of which is a nested tetrahedron at 45 degrees relative to the polar axis of the molecules. Together in a circuit, there is a 90-degree phase separation, which allows the resonant energy to create the needed harmonics to fully resonate both materials. This is the application of the rule of nines. It is a standard, the standard of the geometry of the universe, it is the ruling law of nature, and it is the measuring tool for all electrical and mechanical interaction. If, as some have suggested, the ancient sacred knowledge was shared by extraterrestrials to permit the construction of the pyramids, and if, as we have seen, resonance is the key to anti-gravity as well as to free energy, then the tetrahedron has very far-reaching implications. Meeting the 1 Watt Challenge by Hal Fox. New Energy News 3, 6, 19-21, November 1995. The magnetic resonance amplifier tests. We have received copies of 2 official reports from independent laboratories that show power out ranging from 1.6 to over 4 times the input power to a magnetic resonance amplifier. One of the important factors in this device appears to be the type of magnetic material used as the core of the transformer. The transformer appears to be the most important component in this unusual energy amplifying circuit. Keeling BBS messages. Message 9850. December 13, 94, 9:31. From Joel McLean. 2. All. Subject, MRA input. For those who plan to build their own MRA, you will have to use sine wave signal wave input. I've tried square wave, and although the magnet will sing, the output DC power will be below unity. I believe this is because the circuit can't breathe evenly with square wave input. Message 9875, December 13, 94, 1923. From Joel McLean. 2. All. Subject, MRA Tech Bulletin. If you build your own MRA, there are a few things that you should know that aren't in the file yet they're still being discovered. First of all, don't wear your quartz watch while you work on the MRA, as the quartz will react with the circuit and run slow. Secondly, avoid using scopes for anything except occasional waveform checks, because there is so much flux in the air that it will build up on the scope and skew your display. Thirdly, use a handheld as opposed to a panel meter if you can, because the flux buildup on a panel meter chassis will destroy the front end transistors. I know, as I did it. Fourth, the constant ringing will drive you nuts and give you a headache in short order. Fifth, if you take the piezo out of the circuit after it has been on for a while, as it cools, it will keep building up charges, and will bite you when you pick it up. Sixth, if the piezo screeches, shut the MRA down and wait for a while before you start it up again. The piezos are bad-tempered if you overdrive them, and will sulk for a while before they work right. This ain't your daddy's Oldsmobile, we're still learning to drive it, so there may be more of these field bulletins. Joel. Message 9876, December 13, 94, 20 o'clock. From Norman Wooten. 2. Bill Beatty. Subject, MRA. Bill, Point well taken. We will prove out the circuit and you will know by the message traffic as to our progress. We all value your input and guidance, therefore jump in and help us out as we sort this beast out. I have a very similar circuit to Joel's and we compare notes constantly. I wound a coil on a barium ferrite magnet with my windings running parallel to the block wall where Joel's coil has the windings running perpendicular to the block wall. My I/O ratio so far as I can determine is around 12:1, which is some improvement, but we need testing. Birdpool just left to go and build a similar circuit, so the more folks that build, test and improve on the design the better. Thanks again. Norm. Message 9882, December 14, 94, 8:17. From Norman Wooten. To all. Subject: MRA, Tech Bulletin. Since Joel and I have created a lot of interest in the MRA device, we will place everything online so that no stone is left unturned. Long ago I saw a sci-fi movie of a suitcase-sized device that you could plug any size AC load into it and it would power it with no problem. I dreamed of building such a device by employing a block of natural quartz with a mechanical oscillator attached to all faces, Tesla oscillator, to force the quartz to yield free electrons. I envisioned the output, high voltage, to be stored in a capacitor bank, 1 kJ, then the output going into an inverter circuit and step-down transformer to take this piezo-generated voltage down to a useful AC voltage. Now Joel and I have combined this effect to the resonating of the lattice structure of a magnet to sum the outputs of the piezo effect and the ferroresonant effect to give an over-unity total at the bridge rectifier. Last night Birdpool came over to gather up the needed supplies to build a prototype circuit to do independent evaluation. After I had run the circuit through the paces, noting the outputs and thoroughly discussing what we thought was going on here, I turned off the meters, scopes and the signal generator and finally went to bed. Well, I woke up at 2:00 a.m. with a headache, went to get the Tylenol and went into the room with the test rig on the bench. I turned on the frequency counter and found that the circuit was running in free oscillation with no input. Although no power was being produced, the free running oscillations were filling my living space with a high frequency ultrasonic squeal that, as Joel has warned, will give you a migraine headache in short order. The free oscillation was DDS around 44 kHz with the frequency counter ranging up and down, no lock on. I had to take the circuit apart to stop the ultrasonic ringing. As Joel has pointed out, these titanium zirconate transducers, once set into resonance, will continue to ring for a long period. Since there is possible some conditioning taking place within the crystalline structure of the material, I believe that over a long conditioning period, burn in time, the whole circuit can be make sensitive to a combination of two frequencies that are necessary. The first frequency involved is the input to drive the transducer, which has to be 3 octaves down from the fundamental natural frequency of the ferromagnetic resonant frequency. Although it has not been mentioned before in a public on this net, Joel and I were successful in isolating and identifying the fundamental ferromagnetic resonant frequency as being around 174.9 kHz. Doesn't it sound ironic that this frequency should fall so close to what the quorums have determined that Tesla designed his big coil out in Colorado Springs around? I have read several articles that speculated that the ferromagnetic frequency or the Earth natural magnetic field resonated around 180 kHz. With this 174.9 frequency in mind, we have applied the Joel-McLean rule of nines to the circuit, where we run the transducer at a frequency that is a multiple of the fundamental 174.9 ferroresonant frequency. His circuit is running at a fifth and mine is running at a third. Example: I input a sine wave signal at 2.28 volts alternating current into the series resonance circuit at 59070 Hz and get a voltage developed across the transducer of 26.04 V and a voltage across the coil of 24.02 with an output voltage from the bridge rectifier of 30.2 volts direct current. If everything is running in an ideal phase relationship, transducer oscillations and ferrocoil oscillations, then the beat frequency will partially sum the two voltages since they are in a series circuit and set up a circulating current in the primary, which when the primary winding and the secondary windings have the proper impedance matching will extract the maximum amount of energy from the circulating current in the transformer into a healthy output at the bridge, which is far over unity, high input to output ratio. My circuit is showing a 13:1 ratio at this time, and I have not even approached a good impedance match in the windings. A real sharp RF engineer could sort all the details out in short order. I don't profess to be an RF engineer but have a good background in electronics. This is the reason for Joel and I going public domain with the circuit, so that some highly skilled folks out there can take the circuit and help develop it into something of practical use. We don't want profit-motivated people to rip off the idea for self-gain. We want any potential benefits of the circuit to remain free for the taking. More notes as we learn more. As Joel says, we are like teenagers learning to drive dad's olds. A little help from interested fellow researchers is welcome. Norm. Message 9883, December 14, 94, 919. From Norman Wooten. 2. All. Subject, MRA, Tech Bulletin. In our discussion of the MRA circuit, we keep referring to the key part of the circuit as being a transducer. Let me clarify this a little, for I know there are a lot of folks out there who will be running around looking for that same device that we have. First, let's settle the confusion about the type of material involved. Jerry Decker and I bought some of these devices from Tanner Electronics here in Dallas and were told that they were barium titanate transducers made for the ultrasonic heads in the ultrasonic welders used in the plastics industry. There are numerous manufacturers of such welding devices in which they stack these devices, each rated at 50 watts, to get the total power needed to weld plastic by kinetic contact heating. A physical description is: 2-inch outside diameter round with a 5/8-inch hole through the center with a thickness of 3/16 inch with silver layered on each side, which is convenient for soldering leads to the transducer. When employing these units, they have to be suspended so that they are free to resonate. Don't lay them on a table or surface, for this will dampen the free oscillations. We have not consulted an acoustical engineer to determine the best way to mount the units or attach the input to output leads so as to provide the optimum free resonances. We have discussed the employment of tuned pipes of the proper wavelength ratios needed to enhance the free resonant or targeted resonance that we desire. I have even thought of a mechanical type of tuning fork device that would give us the Tesla described child on the swing type drive that would give the maximum output with the least possible input, wattage input to output. A good microwave engineer would possibly come up with a tuned cavity resonator which would drive the transducer at the optimum phase to extract the energy needed to drive the ferroresonant coil in the primary. The magnet that Joel is using is from an IBM hard drive and is as follows: ADB 7 inches long x 2 inches with a magnetic block wall across the thickness. For those out there who may never heard the term block wall, it means the neutral plane in a magnet. The magnetic orientation is across the thickness of the magnetic, therefore cannot be described as a bar magnet which has its magnetic orientation along the long axis. By using a magnet which has the flux across the thickness and the windings are wound around the center of the long axis, we have a coil which is wound with half of the winding turn in AN field and the other half of the turn in AS field. Makes no difference, since the objective here is to ring the magnet into a resonant frequency, and it seems to me that it is easier to ring, mechanically, with the ends of the long axis protruding from the coil. In other words, the node point is under the coil with the free ends oscillating. There are several ways to suspend a bar that is in free resonance. All you have to do is open your door chime and look at how the chime bar is mounted to extract the maximum acoustical energy from the hammer strike. The same objective applies here, so there is a lot of work to be done to maximize this device. It is public, so you can help sort it all out. Joel is using 150 turns in the primary and secondary of his ferromagnetic transformer. Experimentation will provide the ideal ratios and impedance matching. Get with the program and provide free exchange of findings so all may benefit. Norm. Message 9930, December 16, 94, 1804. From Joel McLean. 2. Norman Wooten. Subject, starting over. Hi Norm tilde I'm breaking in another piezo. It's been on the signature gen for a few hours. I have 1.33 volts alternating current at 34.2 kHz from the signature gen, measuring current in line. Current starts at 4 mA, then slowly drops for about 3 minutes until it gets down to just 1 mA. Since the 133 VAC is RMS, input power to the MRA is 133 mW. Output is 3.1 volts direct current across 4.7 kilo from the decade box, which calculates at 2.0 milliwatts. Since the meter is rated at 200 kHz, I know that we are well within its range. Gain at this low level of signal is 150%. We will learn how to condition a piezo from this, which we can pass along as another tech note. It looks like we have to start at the leakage threshold and work up in terms of power applied. It will take a lot of tests to keep from conditioning parts until they are just barely marginal under useful load. Oh well, nobody ever said it would be easy. The noise from the magnet is amazing, even at low power. Joel. Message 9949, December 17, 94, 9:39. From Norman Wooten. 2. Joel McLean. Subject, MRA. Joel I have had my version of the MRA running for about 14 hours to condition the magnet and the driver piezos, so when I visit you we can do some parallel testing on the two circuits for more verification of over-unity operation. After running all night, the circuit is definitely in the plus column, so we need to nail down the degree. I will bring out my scope Tektronic 80 MHz with a current probe, so maybe we can further bracket that elusive input figure. Everyone agrees that when you are dealing with alternating current at 40 kHz with harmonic bucking taking place, it is sometimes very difficult to pin down the real input wattage. The equivalent resistance test that you are doing is, I guess, the only way, except for some sophisticated equipment that Hal and John have down at the Institute for Advanced Studies in Austin. More later. Norm. Message 9951, December 17, 94, 10:50. From Joel McLean. 2. All. Subject, MRA in conventional theory. The MRA is a series resonant LC circuit in which power gain is attainable as a result of the increase in effective impedance under certain operating conditions. When the series impedance increases, primary current is reduced. When the power available from the secondary coil either remains the same or increases as the primary circuit impedance increases, a power gain occurs. This is not possible with a series resonant circuit made of conventional materials. Even unity power transfer is considered to be unattainable as a result of accumulated losses in the components, which are passive, reactive devices. Materials and construction methods are chosen for these components based upon the type of application and frequency to be applied, with the goal of minimizing losses. A typical capacitor with polyethylene dielectric has a dielectric constant of 2.3 times air. Air has a constant of 1.0, and is the basis for comparison. Titanium dioxide, however, has a dielectric constant maximum of 170, and a corresponding power factor of only 0.0006, comparable with polyethylene, so that the dissipation of primary current in the dielectric is extremely low. This is where the comparison ends, because the titanium composite capacitor is also a piezoelectric device as well as an excellent capacitor. Heat adversely affects the power factor of most dielectric materials. Titanium zirconate, however, contains polar molecules which rotate as thermal pressure is applied. This rotation increases the dielectric constant if the frequency applied is equal to or lower than the resonant frequency of the dielectric. At series resonance, the rotation of polar molecules contributes to heat. As the dielectric constant increases, a corresponding release of free electrons occurs, as a direct result of the piezoelectric properties of the device. In application, the MRA is tuned at resonance for maximum power transfer, then detuned slightly for maximum power gain. This relates directly to the use of thermal pressure at resonance, and the effect that this has on continued polar rotation and the release of donor electrons. The coil, or primary of the MRA, is a magnetic core which, relative to the fixed capacitance of the piezo, is a tuned permeability device. This is often used in RF devices to attain a stable resonant frequency. Magnetic materials are chosen based upon the operating characteristics of the intended application to reduce eddy currents in the operating range. In these applications, the resonant frequency of the magnet itself is avoided, as this would beat with the oscillating current. However, in the MRA, this is the exact effect which we want. The barium ferrite magnet resonates audibly at frequencies which are harmonics of the series resonant frequency. The effect of this in a typical audio application is called harmonic distortion, and is not desirable, but once again, in the MRA, this is what we want to occur. There is energy in the harmonics, and this energy serves to both counter eddy losses as well as to oppose primary current flow, while contributing to circulating current within the resonance circuit. The net effect of this is that when the MRA is detuned, harmonics of the audible frequency beat with primary current, opposing its flow, while the increase in circulating current couples more power to the secondary, and therefore to the load. This is how the power gain is attained, basically by considering the naturally occurring harmonics as beneficial instead of as undesirable effects to be filtered out. When the MRA is detuned, the effective impedance increases as seen by the source, while the power available to the load decreases in less proportion. This is measurable by using resistive equivalent circuit testing. However, the detuning is load dependent, and slight adjustments are required if the load requirement is greater than the power band of a harmonic interaction. After retuning, the power to the will increase in quantum intervals as the circulating current is reinforced by the reaction of the permeable magnet core. This will be seen as slight incremental voltage increases across the load device. Once the magnet is ringing, its frequency and therefore harmonics remain stable, as long as the series resonant range is not exceeded. Therefore, the detuning affects the piezo only, and the circulating current increase is a result of the phase relationship between the harmonic and the source. Voltage amplification is seen across the primary, measurable higher than the source voltage, and this is seen by the secondary. This is not the same thing as a power gain, because the power gain is a direct result of effective impedance. It should also be noted that the term virtual rotation has been applied in describing the operation of the MRA. The comparison is made with a generator, in which relative motion occurs between a coil and magnet. Rather than use physical energy to rotate a mass, the MRA uses resonance to rotate the energy. This is seen in the polar rotation of the piezo dielectric as well as in the molecular energy occurring in the reactive component of the magnet, i.e., the ringing. The lattice structures of the piezo and magnet are compatible for virtual rotation, and the materials complement each other electrically. In the past, researchers have noted many effects which occur at aggregate resonance, which typically includes a range of 3 octaves. Anomalous energy gains were referred to as etheric. The ether was believed to exist outside of the 3 physical dimensions, and could be tapped for free energy at resonance. Etheric energy is said to be limitless, but to vary locally with increases in Earth magnetic fields at sunset and sunrise, like the tides of an infinite ocean. This effect is not thoroughly understood, but has been observed in the MRA, as increases in output in the early morning, and decreases in the early evening. This is still being studied. Experimentation will determine the optimum MRA design for a specific range of applications. Message 9964, December 17, 94, 1431. From Norman Wooten. 2. Bill Beatty. Subject, MRA. Bill tilde yes Joel and I both have Tektronix scopes and Fluke 87 true RMS meters to cross-check all measurements, and so far we cannot find the flaw in the test procedure if there is one. The only real test is independent verification, which will be done by Hal Puthoff and John Down in Austin. If you saw Jerry's message to me, I will be sending Walter Rosenthal a complete running circuit for a second verification along with a complete set of all the message traffic and tech bulletins to date. Joel and I have done all we can do as to verification due to not having some very advanced equipment. The next step is on the workbench in the form of a voltage regulator stage, an oscillator stage and a MOSFET driver stage to drive the front end of the circuit so we can run it standalone. Norm. Message 9966, December 17, 94, 1545. From, Bill Beatty. 2, all. Subject, MRA piezo source. The HNR catalog has lead zirconate titanate piezos, 1.5 by 1/10, 50 kHz. Think it'll work? Message 9967, December 17, 94, 1817. From, Norman Wooten. 2, Bill Beatty. Subject, MRA. Bill Yes, those transducers will work but they are physically smaller than the ones we are using. I figure when the circuit is verified that the next step will be to go to a natural quartz milled wafer of the natural frequency we desire to, same as the crystals used in transmitters except a lot larger. If you have access to a Thomas directory at work, please look up Branson who makes the ultrasonic welders so we can get a source manufacturer from them. Maybe someone on the internet will know the manufacturers of these transducers. This circuit is a mind-bender when you study its characteristics. For example, I started off this morning, after I let the circuit run all night to condition the magnet and piezo crystal, with a total over unity power gain of 1.65:1 ratio. After playing with the circuit all day taking measurements after each adjustment or change of operating parameters, arrived at a 150:1 input/output ratio. Here are the figures. Input 15.34 volts alternating current at 54.9 kHz with 0.57 mA which is 0.000874 watts, which has to be adjusted for power factor by multiplying by 0.707. The output is 16.75 volts direct current at 78.8 mA into a pure resistive load. This figures out to be greater than a 150:1 I/O ratio. I guess you have figured out how excited everyone is over this gadget. Now, unless Ohm's law has been nullified or there is some spook phenomenon that Joel and I cannot find, then we have the 1 watt challenge in the bag by a wide margin. More as we learn more. Norm. Message 9982, December 18, 94, 1013. From, Norman Wooten. 2, all. Subject, MRA, Tech Bulletin. I know that there are quite a few folks out there running around digging up parts to build a MRA device to do independent testing. Let me share with you some findings that will assist all in this approach. First, disregard the measurements that I gave Bill Beatty yesterday in a message about power gain. I, like Joel, find myself back at square one. It happens like this: when you have this circuit up on the ragged edge where the first harmonic seems to be phase beating or attenuating the input current and providing potential only to drive the first stage resonance in the transducer, you disconnect the load to do the only accurate total power consumption test, which is equivalent resistance measurements, so we can nail down the elusive power figure according to Ohm's law. Well, when you unload the circuit under the optimum operating conditions, the transducers will immediately trip into a very powerful mechanical oscillations around 2 kHz and self-destruct in short order, and at the same time put out a violent voltage that can soar above 1000 VAC, which in turn will literally wipe out your driving amplifier and your frequency counter. Fortunately, the scope is better protected on the front end. So what I am saying is that you begin all over conditioning a new set of driver transducers which even fresh out of the box will display over unity output in the circuit. The people over at the manufacturing firm that makes these transducers are smiling and calling their stockbroker to exercise some stock options in their product, for I see a lot of you destroying a bunch of transducers in the process of testing and improving the circuit. Let me share with you some ideas. When I go back and read Tom Bearden's works about potentializing a circuit without the attendant circuit that is normally involved, we will have achieved the over unity that we are seeking. After careful study of the MRA, I can see how this device can be separated into two separate devices. First, the piezo is a source of high frequency potential which at 3 octaves above drive the ferroresonant primary coil at the natural resonant frequency of the magnetic material. Now I believe I have figured out the secret behind the Swiss ML converter known as the TESTAVISTATIKA or TESTATIKA for short. This device was developed in the group called METHERNETA by Paul Baumann, and it has been seen by our friend Stefan Marinov. This ZPE tapping can be accomplished through potential being derived from any source such as the electrostatic charge developed in the Wimshurst type generator. The secret is in the magnetic resonance amplifier. Ken Shoulders and Rear Admiral Ford demonstrated that what we term as harmless energy, electrostatic charge, when stored in a large capacitor is real charge separation and can do some interesting things such as exploding water, wire and other interesting research projects. If we take advantage of the mechanical oscillations of the transducer and operate it at a level of mechanical resonance, in free oscillation, that will optimize the voltage output, let's say 400 volts, which in turn we use to drive the ferroresonant barium ferrite core coil, then we can extract some serious power from the coil providing that we have done our homework and provided the optimum impedance matching and tuning of the circuit to maximize the final product. We are a long ways from our final goal of having a unit that we can flip a switch and the thing will run standalone. Joel and I have taken the first step by sharing with you our findings, so let's work this thing out together as a joint project. We will share all findings in these tech bulletins so everyone is on the same sheet of music. Now for some spook type anomalies that occur around this circuit when it is running in the ZPE tapping mode, which is where we purposely detune the circuit upward in frequency so that we get the beating effect from the first harmonic. When you see this on the scope, it will appear as the sine wave pattern of the input being broken into little line segments by an invisible or transparent oscillation at a much higher frequency than the primary driving signal, which in the case of my circuit is around 56.8 kHz. Even when I have chapter 2 turned on with no signal, base line only, it also is broken into short line segments as if the electron beam is driven into cut off by this invisible signal. Any RF engineers out there seen this? Please explain same. I believe that all the phenomenon that is being observed by people such as Sweet, Aspton, Adams, Lambertson, Searle and Tom Bearden are all connected by a common thread. Let's unravel it. Norm. Message 9983, December 18, 94, 1103. From Joel McLean. 2. Jerry Decker, SysOp. Subject: Piezos are fragile. Hi Jerry. The piezos, for all of their 50-watt capability, are fragile, especially along the edges. I had mine soldered at the edges, and when it bumped into the magnet while in transport, it cracked. The piezo has to be free to vibrate. If you touch it while the MRA is running, you can watch your output drop off, so it's a question of finding a way to mount them loose, yet protected. However, whoever accidentally picked up my stapled pack of tech notes might let me know so I can pick them up, has all of the test data and correspondence with Hal, and was on the corner of the table. Thanks. Joel. Message 9984, December 18, 94, 1113. From Norman Wooten. 2. Jerry Decker, SysOp. Subject: MRA. Hey. Jerry, Don Smith is right all the way. Let me explain. He has basically the same circuit that we, Joel and I. In his circuit he is using a Tesla coil as the driver and trying to extract power in his secondary from the feeble background Earth magnetic field. If Don had been privy to what Joel and I know, now everyone, then he could have incorporated into his circuit a powerful barium ferrite magnet which he could drive at its resonant frequency and effectively do the same thing we are doing. In fact, the Tesla coil instead of the transducer is a much better driving potential. It is inherently much more stable with much higher potentials being able to be achieved, and the fact remains that the ZPE tapping occurs in the domains of the magnet in virtual rotation. Thoughts Jerry and Joel? Norm. Message 9985, December 18, 94, 11:55. From Joel McLean. To Norman Wooten. Subject: Tiger by the tail. Hi Norm tilde sorry to hear that you also blew up your input amplifier. We've got a very powerful tiger by a very short tail with the MRA. Its purpose is to give power gain by bucking input current while using circulating current to drive the load, and this is done in a tuned, balanced state. As we've seen, unbalancing the MRA by removing the load can cause the bucking current to run open and blow up 40 to 50 watt amplifiers with no other power applied. Even the flux from it blew up my panel mount DVM. Well, the good news is that we are over unity, the bad news is that we will have to cage the beast somehow. Tilde Joel. Message 10033, December 19, 94, 10:46. From Jerry Decker, SysOp. To Norman Wooten. Subject: R, MRA. Hi Norm/Joel, ET. Al tilde just got a call from Tom Bearden. He's excited, and even though I sent the MRA to him last week, he wants it today, so I am faxing it along with the MRA1 and the UJT-OSC, Woody's UJT oscillator file, because he can use all of it. As to the fracturing, he says this is due to pumping the potential field and went into a long explanation that I don't remember half of. He says his paper on step charging of the capacitors warns of this and they still haven't figured out how to get around it. He says they have transients exceeding 3000 volts and have smoked several test instruments on their end also. He says to be sure and warn Rosenthal of this before he trashes some of that very expensive stuff he will use. Tom says because the anomalies in such circuits are so radically different from normal electromagnetics, to prevent or at the very least attempt to minimize damage to their test devices and circuits, they have adopted the approach of discrete charging only up to fixed levels. It is everyone's desire to get the max power out, but not at the expense of blown equipment, ruptured parts or circuits that burn out, so he thinks once the grad students and others start getting into it, they will work convergently, as everyone here does, to come up with the bottom line details of what works, what doesn't, and what will produce anomalous effects. So, I have to get those faxes to him now. Again, he said he is so very pleased that everyone is working so well together and that the information is being so freely shared. Tilde Jerry. Message 10041, December 19, 94, 12:10. From Joel McLean. To Birdpool. Subject: MRA at preamp signal input. Hi Bert tilde at the meeting, you were talking about energizing an MRA with low-level signal input, so I gave it a try with a weak stereo preamp. The input to the MRA was 0562 VAC and 11 mA for 62 MW of input power. The output power is only 22 MW. After an hour, the input power dropped off to 42 MW as the circuit equivalent resistance increased from 510 ohms to 10 k ohms, and the output power stayed the same at 22 MW, but this is still only half of unity. Even given more hours of test, I don't think it will make unity. It's possible that the weak potential and resulting current are not enough to create the flux density and piezo effect that we need. Tilde Joel. Message 10054, December 19, 94, 21:14. From Joel McLean. To Norman Wooten. Subject: R, MRA. 1.90 volts alternating current at 34.11 kHz. High norm. Signature. Using this circuit in the MRA Gen, I've been able to measure the primary current without the ref A piezo effects of the voltage multiplication or the inductance of ref B wire wound resistors. /8 ohm comp. With the 8 ohm resistor wired resistor between the piezo and primary. And measuring from the return side at ref A to ref B and to ref C, and subtracting them. You have the voltage drop for 0 calculating series current. 0 primary. 0 winding. I have 11.15 volts alternating current at ref B and 0 11.10 volts alternating current at ref C for 0.050. Drop, /8 equals 0.00625 amps, times 1.90 volts alternating current for 11.9 milliwatts. On the output, not shown, is 5.80 volts alternating current across 600 ohm resistive load for current of 9.7 milliamps and power of 56 milliwatts. Gain is 56/11.9 equal 4.66 times unity. Please try this and let me know what you get. Joel. Message 10059, December 20th, 94, 7:55. From Norman Wooten. 2. James Hartman. Subject, MRA/gravity. James – we have your speaker levitation experiment on the net as a file. A couple of days ago someone mentioned the harmonic-rich waveform of the MRA as being the same as your output from the distortion amp when you were getting the levitation effect with the correct fundamental frequency applied. All goes back to Keeley with the multiple frequency discord causing anomalous gravity effects. Sure wish you luck in the pursuit of follow-up info on the English report. With the Nipper ring project we will need as much info as possible to achieve full anti-grav effects. Norm. Message 10071, December 20th, 94, 1404. From Joel McLean. 2. Norman Wooten. Subject, E-line tests. Hi Norm – I like the idea of using the solid-state amps to measure current differentials. I've tried to measure the difference in AC current to the signature gen by measuring the voltage drop across a 2 ohm resistor in series with line to the signature general. Even with a SOLA, there is more line variation than the 0.001 VAC difference in drop that would equal the entire output power of the MRA. 0.001/2 times 119.2 volts alternating current equals 60 milliwatts. So, measuring input power in this way is out of the question. Joel. Message 10090, December 21st, 94, 418. From Bill Beatty. 2. Norman Wooten. Subject, fractured traces. On your strange oscilloscope results, I see this often, when the chopping frequency gets close to the frequency being triggered upon. If you are seeing these segmented traces when the scope is in alternate triggering, or on a single channel scope, then it is real. But the chopper on a dual trace scope can easily create moving line segments of various kinds without anything weird going on. Oh, I meant that I see it often at work, when doing frequency sweeps on circuitry. Message 10094, December 21st, 94, 7:39. From Bob Paddock. 2. Norman Wooten. Subject, MRA. Another interesting thing that we verified tonight was that the natural ferromagnetic frequency is approximately 174.9 kHz. This is a shot in the dark from my failing memory. I remember reading in my collection of one device that worked at 14.7 kHz. I don't remember the name of it for sure, but it was the one made with the large basket weave coils, Hendershot maybe. You've probably seen the thing. It is one of the common lead gen devices in this field. 174.9 kHz/12 equal 14.575 kHz. 14575/1944 equals 7.49 Hz puts it down around the Schumann range. A harmonic interaction with the earth field? This could account for the time of day effects. Do you note significant changes at sunset and sunrise? Maybe this is significant, maybe it is not. Message 10096, December 21st, 94, 811. From Norman Wooten. 2. Bob Paddock. Subject, MRA. Bob – yes, as Joel has mentioned several times in the message base, we do get variations in the output of the MRA at morning and evening testing. Highest output is early morning as the sun is coming up. I agree with your magnetic frequencies, for I have read many different theories, each with a different frequency associated. Joel and I feel that we have it narrowed down through better evidence than previous researchers. We will soon know for sure with a few more tests that we have in mind. We'll keep you posted. Yes, please send the Harris catalog, Norman Wooten, P.O. Box 141049, Dallas, Texas 75214. I'll see that Bert has access to it, for he is the circuit guru. Loves to play on the soldering bench. I would like to get your comments on the 12 volts direct current powered audio amp test we did, where the total current draw went down from an idle draw reading to a reading with the MRA in the circuit. Do you have reasonable explanation for this? Joel says that this little Radio Shack stereo booster 40 watts amp is class C, therefore can only go up on current draw when a load is applied. If idle DC current draw is 344 milliamps and goes down to 192 mA when the MRA is attached, then what are we seeing? Should we attach a thermocouple to the output transistors to see if they are making ice? That is the only phenomenon that we have not found that is usually associated with ZPE type devices. For those that are new to the ZPE or space vacuum tapping scene, there have been numerous reports of over-unity type devices that usually have one or more of the following phenomenon associated with their operation. 1. Over-unity output of energy of some sort, whether it be heat, electrical, mechanical or light. 2. Weight loss, anti-gravity tendencies. 3. Cooling in the immediate area or in the device itself. Joel and I would appreciate any and all comments. Norm. Message 10099, December 21, 94, 11:44. From Joel McLean. 2. All. Subject: MRA anomalies. 8 days ago, the MRA was invented. Almost immediately, it began to exhibit over-unity characteristics. However, there have also been a lot of quirky effects, each taken separately might have been test equipment error or technician error. However, these effects are forming familiar patterns now, familiar but not always predictable. The toll in dead and damaged test equipment so far is 1 panel mount DVM, 1 frequency counter, 2 audio amplifiers, and numerous 60 WATT light bulbs. Sometimes, when supplying the MRA from a 12 volts direct current powered audio amp, the battery current will decrease compared to the battery current to the amp with no load at all, and at the same time, amp output voltage will increase. Taken together, this indicates that the MRA is feeding energy back into the amp. Later, with no changes to the circuit, the MRA will behave like a normal load, and cause a small increase in battery current with a small decrease in amp output voltage. The voltage and current waveforms look like dotted lines, where each dot and space segment is equal to 175 kHz, which Norm and I believe is the free-running resonant frequency of ferromagnetism. We have never seen this before, and for that matter, neither has anyone else that we've talked to about it. Even with nothing on channel B of the scope, the display will exhibit the dotted line effect whenever the MRA is running and connected to channel A. Anything and everything in the field of the MRA is affected. Should the MRA's output load become accidentally disconnected while the MRA is at resonance, an instantaneous and very powerful destructive surge will occur. I think that the MRA, by resonating a magnet at mass aggregate frequency, is magnetically linking with everything in its field, and behaving like an energy pump. We see this when we walk up to it and the output from the MRA goes up, even though the MRA is hooked up to a resistive load which is causing it to provide current. This also changes based upon the time of day relative to sunrise and set. To test anything, you first must isolate it. By virtue of the design of the MRA, it cannot be isolated. It intrinsically links itself to everything with a coil or magnetic field, even to a quartz wristwatch if it is in the same room. As such, we get varying power gains, and the variations seem more to be a question of which test equipment is on the table at the time of the test. Please bear in mind that this is a brand new circuit as far as that goes, it's a whole new technology. Once the magnet has been resonated, and then disconnected from the rest of the circuit, it will continue to provide up to 25 volts at 60 Hz using a human antenna to capture ambient energy in the room. Last night, Norm and I were measuring over unity gains of 2x, 3x, but we don't really know for sure if we were pumping the energy electromagnetically out of the test equipment, house wiring, Earth's magnetic field, the ether, or some combination of the above. We need some independent testing by individuals with awareness of the anomalies mentioned in this message. There is obviously a lot of power in flux which collapses into the MRA if the load is removed, so there will probably be more equipment lost. There is also a whole area of gravitic anomalies to investigate, because the piezo will weigh measurably less when it is in the MRA circuit, and regain the weight when it is disconnected. The original MRA is being sent out for engineering review, from which we hope to learn more, but the more voices that are heard from, the better our chances of finding out what is really happening. Joel. Message 10103, December 21, 94, 12:29. From Joel McLean. 2. All. Subject, Addendum to MRA anomalies. If the MRA's gain is caused by pumping energy from the test equipment, house wiring and Earth's magnetic field due to electromagnetic linkage, would that be the same as wireless electricity? Tesla used the same frequency which is affecting our oscilloscope trace. Since the MRA is sensitive to sunset/sunrise, is it then going to exhibit higher gains at ley lines and grid intersections? With more power applied, will the MRA achieve zero gravity? Why do we only see the effect of 175 kHz on the scope, and not the waveform? Is it scalar energy being translated by the scope? If the MRA is linking with Earth's magnetic field, how can we isolate test equipment, or for that matter, anything else on Earth from it? Send all answers and any light bulbs you can spare to Joel and Norm. Message 10104, December 21, 94, 14:11. From Bob Paddock. 2. Norman Wooten. Subject, MRA. Bert wants more info on the indestructible transistors you mentioned. Call up Apex Microtechnology and ask them for a data book, 800-546-APEX. They make driver integrated circuit/op amps that will run on ±- 600 volts direct current, 1200 volts direct current total swing, at 0.5 amperes, and other power parts. They also have some parts that are spec to 15.000V/USDV/DT. DV/DT may be what is burning up things rather than the absolute voltage. Some parts might be able to handle 1000 volts direct current, but only if rise is slow enough. Too fast a rise and you've got toasted parts. Check out the app notes in the back of the book on such things. The bad news are these things cost big bucks, $30 to $500, but can still be a bargain when you consider the system equivalents that they replace. First, this bad news: the following part does not appear in the 1994 data book, bad sign. From the Unit Road 1990 data book, the Unit Road UC195/UC395 family of devices are ultra-reliable, fast, monolithic power transistors with complete overload protection. The devices act as high-gain power transistor and have on-chip, current limiting, power limiting, and thermal overload protection, making them virtually impossible to destroy. Doesn't look like that will help much since we can't get them. I'm still tracking down the NS part. They sold off their transistor division. And I have the indestructible audio amp data sheets on order. Another company in the power area is Supertex Inc., 408-744-0100. I'll keep looking for indestructible parts. Message 10112, December 21, 94, 1830. From Norman Wooten. 2. Joel McLean. Subject, MRA. Joel. The MRA is as we speak on a FedEx flight to California going to Walter Rosenthal for the independent testing. Maybe you could write up some input and set up guidelines for Walter so as to assist his testing effort. After all, this is your hand-built version. If you would, run a few test runs on my monster MRA and we will send it to Hal down in Austin, or we could simply just wind another exactly your original so they both would be testing identical units. What do you think? Norm. P.S. I'm waiting for an explanation as to why the overall current draw went down on my MRA when we tried the 12 volts direct current amp test. The 50 milliamps rise was on your version. Remember, we broke off the test when we got negative numbers. Infinity gain Norm. Message 10113, December 21, 1923. From Joel McLean. To Daniel Hill. Subject, R, MRA. Hi Daniel. If we need RMS power for comparison with, for example, changes in the input power, yes, we use the constant multiplier of 0.707, which is in the file info that we provided. Whether this is the exact phase angle for this circuit, without vector analysis, we don't know. The reason why we can't be sure is that we are vectoring harmonics for the express purpose of altering the effective impedance of the circuit. This is not what they teach at DEVRI, but it is how it works. However, the world accepts the cosine of theta at 0.707 as the normal AC circuit power factor multiplier, so we use it. To the extent that the calculated output power performs the correct amount of work, such as driving a motor, it is as close as we can determine to be accurate. Joel. Message 10116, December 21, 2208. From Norman Wooten. To Joel McLean. Subject, MRA. Joel. Gremlins are back at work. I started to take the power amp back to Radio Shack today but decided to do a test on it first. Glad I did, for it healed itself. Remember what I said about my circuit shutting down and would do nothing? Well, I think this MRA builds a field up around it and blanks out some equipment. The amp is okay now and operating just fine. Tonight I was running a new MRA like your original and suddenly it shut down and I could not get any output from the secondary no matter how much I increased the input to the piezo. The only way I solved the problem was to swap sides on the circuit, in other words swap the output leads over to the input and vice versa, then it took off running again. Glad this is a 1:1 turn ratio winding. This a really weird device that will take some getting used to. Norm. Message 10131, December 22, 1426. From Joel McLean. To Norman Wooten. Subject, test of the Monster MRA. Hi Norm. Tested the Monster MRA with 2 magnets, large coils and 4 piezos. First tested it with low power from the signature gen only, then with the amplifier. Since the piezos were in parallel, I tested both parallel and series connections. Also tested just the transformer, with no piezos. The transformer alone is just under unity, half of 1% difference in power, at 144.5 kHz. With all of the piezos in the circuit, the power out ratio dropped off. Found that the best gain was with only one piezo, which added 1.2% over unity with the signature gen alone, and 11.8% with the amplifier. I used a regulated 12 volts direct current 10 amps power supply to power the amplifier, so that there would be no chance of current dropping off as load was added, and found that the additional drain to the supply with the MRA connected was 40 mA. It took 180 ohms of equivalent load on the output of the amp to produce the same 40 mA increase, so the MRA looks like 180 ohms to the output of the amp. That is the effective impedance of the MRA, which we can use to determine current and power into the MRA. With 9.73 volts alternating current output from the amp at 180 ohms, and 18.8 volts alternating current from the MRA at 600 ohms, we have 372 MW RMS into the MRA and 416 MW RMS out, which is 1.12 times unity. I think that the reason why the gain isn't higher is that the difference between max power out of the MRA and max power gain of the MRA is too wide of a spread in frequency. We used 85% as a rule of thumb with the first MRA, but this one requires 70% change, which puts us on the edges of the resonant range, and we lose much of the power of the harmonics. I'm not sure whether this is a result of using two magnets or more wire or a combination of the two, but the best power gains seem to occur where the frequency spread between max power and max gain is less. We'll have to experiment with number of turns on a single magnet to find the sweet spot, no pun intended. Joel. Message 10132, December 22, 94, 1531. From Joel McLean. 2. Bill Beatty. Answering as many questions as possible in one message. Bob, your guru is right. The current drop was seen on a DVM, and is likely caused by a meter error as a result of the surge at power on. Also, a drop in input voltage would naturally cause a corresponding drop in input current, so we are using a 10 amp regulated supply to avoid that pitfall. The current increases by 40 mA after the initial surge, as measured on an analog meter. Michael, the aggregate resonant frequency is between 34 kHz and 35 kHz, although we found the resonant frequency of the magnet to be around 8 kHz to 11 kHz. The 174.9 kHz is what we believe to be the resonant frequency of ferromagnetism, based upon Tesla's experiments and some of our own. We don't see this in the circuit on an oscilloscope, but we see wave chopping at this rate. Bill, the signals which we are inputting and extracting are all sinusoidal. We're using battery power as much as possible, although the signature gen is AC powered, and we've had to use a 12 volts DC supply to avoid battery drops during measurements. I'm not sure what the retrace or refresh rates are for this scope, but it should be higher than 175 kHz on a 80 MHz scope, I would guess. Yes, I know how the observer effect is interpreted in mainstream science, except for the folks who work at particle accelerators who have both seen and documented it. There is an interconnectedness of all things, but once it's measurable, mainstream science jumps all over it. God bless them, everyone. Since the original recipe MRA has been sent out for engineering analysis, we'll have to wait until its return before we can use it for more tests. Joel. Message 10134, December 22, 94, 1710. From Jerry Decker, SysOp. 2. Bill Beatty. Subject, R, Addendum to MRA Anomalies. Hi Bill. That's some real food for thought that has applications with a gravity wave detector circuit. It too could be driven over an area and the field mapped to produce a topology. Townsend Brown did this back in the 40s, I think, on a Navy submarine. James Hartman sent me a copy of the book with the details. Nothing spectacular, but it definitely showed gravitic anomalies, way before the mascons discovered on the lunar surface. Excellent idea, Bill. Jerry. Message 10138, December 22, 94, 1749. From Norman Wooten. 2. Jerry Decker, SysOp. Subject, capacitor charging in MRA field. Jerry. I have been thinking about the thread that you and I had going back in the summer about how capacitors could be charged by dropping them or spinning them. Well, Joel and I are going to do some cap charging test via the MRA fields. If we are getting this anomalous energy fields that will show up to 27 volts AC on a meter with everything turned off, it is possible to use the device as a passive tuned energy collector. Sort of like Tesla's cosmic ray converter, in which he charged capacitors and drove simple motor devices. Worth a few hours of test setup. Norm. Message 10141, December 22, 94, 2109. From Joel McLean. 2. Jerry Decker, SysOp. Subject, R, Addendum to MRA Anomalies. Hi Jerry. Thank you. I didn't pick up on the implications, so glad you did. You know, the first G-wave detector that I built went nuts when that last big earthquake hit Japan. It was the electrolytic capacitor with a 747 and a small piezo speaker. Maybe the MRA could be monitored by someone in CA next to a seismograph to see if it can correlate tectonic activity with gravity fluctuations, maybe even help give some warning in advance. It would be worth it just for that alone. Increases in solar wind as a result of solar flares might also be detected in time to shift power lines to avoid power failures. Actually, if the MRA is made directional, it could detect any large energy shift from any source, because they are all reflected on the Earth grid at near light speed. Here in Texas, we could see tornadoes forming. Might just be the early warning system for all natural, and unnatural, occasions. Message 10172, December 23, 94, 2051. From Joel McLean. 2. All. Subject: the 300-turn secondary and 60W bulbs. There was an error in message number 10148. The MRA tested today was made by Norm for test, and has a 2-to-1 step-up ratio, i.e., 150 turns on the primary, 300 turns on the secondary. From what I can measure, this is superior to the original 1-to-1 ratio of the first MRA, which I wound to test theory. Makes sense though, because as the magnet inhales energy, the more secondary you have, the more energy will be collected for the load. Also, have noticed that when light bulbs, ordinary 60 watts bulbs, blow, they do so with great vigor and a brighter than normal flash. The filament is exploded off of its posts, and flies around the inside of the bulb with enough force to leave striations on the glass. In the past, I have associated this with an accumulation of virtual particles on the neutral lines of the house, from other experiments. This accumulation causes the lines to superconduct when a light switch is turned on, because the neutral is no longer neutral but at an elevated virtual potential. The effect is the same. Joel. Message 10175, December 23, 94, 2208. From Norman Wooten. 2. Bill Beatty. Subject: MRA. Bill since you have been such a valuable asset to us in getting out the word to the internet and CompuServe, I am going to send to you an original piezo and magnet of the type that we are using in our MRA devices. As you have seen by Joel's message prior to this one, he has run test on one of my 2:1 ratio MRA units. I have built 6 MRAs to date and all have displayed over unity to differing degrees. I have been playing with different configurations of magnets and winding ratios while Joel is doing the hardcore testing. Heck, most of my equipment is out at his house. Just kidding fro, we have duplicate of all test equipment and so does Birdpool in our group. This way we all three can build independent of one another and compare results. Joel is sending the 2:1 ratio MRA that I built to Harold Puthoff down in Austin for additional testing, while Walter Rosenthal is testing the original MRA out in California. I will get your care package off to you Tuesday along with a document that I want you to post to internet. Norm. Message 10176, December 23, 94, 2356. From Joel McLean. 2. Bill Beatty. Hi Bill. I don't think that all combinations of piezo and magnet types will work. The evolution in the original design was first, the resonating of a magnet, and determining the resonant range of the magnet, and second, adding a piezo which would resonate 3 octaves above the magnet. The magnets which we are using will sing a pure tone at just over 8 kHz, and double that is 16 kHz, and double that is 32 kHz. The frequencies that we are applying to our MRAs is between 34 and 35 kHz. This is also just below the peak resonant range of the piezos which we are using, and which were originally designed for ultrasonic welding. The lattice structure of the piezo and magnet should also be compatible in order to get the harmonics, cube lattices, which are nested tetrahedrons. First wind a primary and secondary around your magnet, and apply a variable frequency to the primary while watching the secondary on a scope or high frequency meter. Where the secondary output peaks, you have the resonant frequency for the magnet. Use that to find a piezo which has a resonant range 3 octaves higher. The easiest thing would be for you to use the same parts that we are using. They have already been found to be harmonious. If you want to experiment with what you have available, that's fine too, and may yield more and better results, or at least useful data on which combinations don't work until you find one that does. You will have to keep your mass aggregate frequency well below 100 kHz, or you will be above the alpha cutoff frequency of audio resistors and diodes. You won't be able to get DC out, in other words. Let us know what you want to do. Joel. Message 10188, December 24, 94, 11:20. From Joel McLean. 2. Bill Beatty. Subject: MRA as a solar device. Hi Bill. As Paul Harvey would say, now here's the rest of the story on the MRA as an energy pump. The energy source is the Earth magnetic field, which gets its power from the combination of rotation and solar wind from the sun, so the MRA is technically a solar power device. As the MRA warms up, it is extending its vortex upward and linking with layered fields of the atmosphere. At each link point, you will see the MRA output increase by a specific quantum interval. The MRA is attracting the electromagnetic energies, and funneling them back to the magnet, through the coils, which couple a portion of the energy to the load. Other conductors which are in the path of the vortex also collect energy, specifically the neutral wires. You can reduce the output of the MRA by detuning it, and within a few hours, the output will be back up as a result of the quantum-linked increases, and regardless of the energy applied to drive the MRA's oscillations. By the way, the MRA does have max output when the coils are aligned with magnetic north and south and drops off when the coils are aligned toward east and west. You are going to have a lot of fun with this. Joel. Message 10191, December 24, 94, 12:18. From Joel McLean. 2. Norman Wooten. Subject: MRA has a magic square. Hi Norm. I think that we have a magic square relationship with the magnet, because when it was resonated in the monster test, it was almost at unity, with no piezo, at 144.5 kHz. If we divide 144.5 by 17.5, we get 8.25 kHz, and 3 octaves up is the mass aggregate frequency of the MRA. Why divide by 17.5? Because it is the kilohertz multiple of 175 kHz, the ferroresonant frequency. Another piece of the puzzle is now in place. Joel. Message 10192, December 24, 94, 12:34. From Norman Wooten. 2. Joel McLean. Subject: MRA. Joel, I built a second 2:1 ratio MRA and began testing this morning after conditioning the magnet and piezo through the night. Well, here are the numbers that, by the way, have all been verified via scope measurements in addition to meter readings. Input, at 34364 Hz, 1.385 volts alternating current at 0.0001667 A for an output of 4.89 volts direct current into 10,000 ohm load at 0.000433 amps on which I have applied no power factor correction on the input, which according to my calculations yields a 9.18 power gain. Check the figures and comments are welcome. There seems to be a big debate going on in various minds as to the application of the 0.707 pF correction when we are not sure of the exact nature of the circuit, i.e., do we have a capacitive leading current circuit or is it an inductive, current lagging circuit? The way I understand power factor correction is that you have to know the degree of lead/lag relationship between the voltage trace and the current trace. Am I correct or not in this statement? Norm. Message 10194, December 24, 94, 14:50. From Joel McLean. 2. Norman Wooten. Subject: the rule of nines revisited. Hi Norm. Connect two MRAs together, with the output of the second connected across the primary of the first. Get them in resonance, and then turn off the signature general. They will become self-resonant exactly 3 octaves above the frequency that you were applying, rule of nines again, and the output power will go up 200 to 300%. Then turn the signature gen back on, and see how long it takes to get the circuit back under control of the signature general. Because we are resonating each MRA at the 3rd octave of the magnet, that means that we are at the 1st octave of a greater aggregate, which occurs as the free running frequency. 3 octaves above 33.75 kHz is 135 kHz, the free running frequency, which is equal to the ferromagnetic 175 kHz minus the magnet residential frequency and the piezo residential frequency. Given enough drive, this bird will fly. Joel. Message 10200, December 25, 94, 1330. From Joel McLean. 2. All. Subject, Creative effect. The purpose of this message is to introduce a new term to describe the type of components which are used in tuned resonant devices. In the past, active has been used to describe switching parts, such as vacuum tubes and transistors. Passive is used to describe components such as carbon resistors, and reactive to describe coils and capacitors, which react to changes in frequency by altering their impedance to the flow of current. All of these devices consume power in application. None of these apply very well to components that consume power but which also use resonance to tap the ether for equal or greater power than that which they consume. Therefore, to fill the void in usable vocabulary, I suggest the term creative. The term implies that something is created, which is not the case. Energy cannot be created. However, the effect of actively resonating material for the translating of energies gives the appearance of creating energy. The components are not creative unless and until they are in the process of creating the effect. This should not be too confusing, as the same relationship exists with other components. A coil, for example, has no impedance, only resistance to DC current. It is passive to DC, and reactive to AC. If anyone has a better terms to suggest, or sees any technical problem with creative, please let me know. Thanks. Message 10209, December 26, 94, 1007. From James Johnson. 2. Norman Wooten. Subject, chopped sine wave. Norm, last month I was plotting sine waves using MathCAD, trying to determine what Keeley was doing with his destructive use of harmonics. It appeared to me that he was subtracting out the 3rd, 9th, 27th, 81st, 243rd and etc. harmonics from the first harmonic. The 6th harmonic may have been added to create a shrinking effect on a molecule. However, he kept saying that large impulses were being created when he was plucking his strings. The frequencies that were creating these impulses seemed to be in the terahertz range, which he deduced from his vibrating hydrogen bubbles and the refracted and reflected light waves. Anyway, while plotting numerous combinations of harmonics, a pattern started to emerge that blew my mind. There appeared to be the formation of a normal low-frequency sine wave that was being chopped into regular occurring parts. These parts were created when large spikes of higher frequencies with fast rise times would shoot up and down from the ends of each part. As each succeeding harmonic was subtracted, the amplitude of the impulses became greater. I was not able to go beyond the 243rd harmonic because of MathCAD's limitations in plotting points. Keeley was dealing with very high frequencies, even though each individual harmonic at these frequencies was not very powerful by itself. The combined harmonics, I feel, produced tremendous pulses that could rip apart most any substance. There appeared also a pattern of smoothing the chopped sine wave as the higher harmonics were being subtracted. You might be seeing these effects on your scope when testing the MRA circuit. The dual trace feature on the scope could be also causing trouble, as already suggested. If it is, throw the damned thing out and use a pendulum or a pair of divining rods. One thing that keeps popping up in Mrs. Moore's book on Keeley is that Keeley seemed to be using segmented silver, gold and platinum wires as well as some bar stock attached to his devices as band pass filters. This appeared to allow him to pass selected frequencies to various parts of his apparatus in the proper sequence. The idea that he produced all frequencies at the same time does not seem to be true. There appears to be a very definite sequence of frequencies applied that created the required harmonics. Those using soundboards in their computers should be aware by now that digital producing sine waves are really chunky when dealing with high frequencies. The MathCAD simulation that I use really brings this home when using less points. Great numbers of points are needed to produce the finer details that are required to observe some of the above sine wave chopping. Message 10142, December 22, 94, 2128. From Bill Beatty. 2. Norman Wooten. Subject, MRA. I wonder if your output rectifiers are a necessary part of the device? Have you tried running it with an AC output and using scope measurements? Might it still work? Message 10144, December 22, 94, 22 o'clock. From Jerry Decker, SysOp. 2. Norman Wooten. Subject, R. Capacitor charging in MRA field. Hi Norm. Sounds like a great experiment. If there is truly a field present, it might even have time distortion effects as with the De Palma claims, since the Nieper and some of Townsend Brown's experiments also seem to dilate time. I never understood if it was truly a time dilation or simply an impeding effect on the mechanical clock mechanism, and that might apply to digital also via electron flow quenching. Perhaps Joel's NEONDET circuit, using the neon to detect scalar type changes, might be useful to scan the area around the device while in operation, and that in turn leads to the gamma emission detector used by Jopar in his rotating pyramid experiments, where the energy bubble grew from the center of the king's chamber. Lots of permutations. It would make the most sense to stick with the normal measurements first, then go to the spook field theories. A capacitor, being a stressed dielectric, might be an ideal collector of such ether interferences. I really like Bill's idea of scanning ley lines and generating some kind of map. I was just talking with Eric Deschênes from Canada, and he mentioned that a geologist friend of his told him the ley lines of the planet are shifting from their position due to large crystal and other mining processes. We also discussed whether these were a man-made grid that was being disrupted by a lack of understanding, or whether it was a natural grid based on the Earth's own geometry. And what would be the effects once it reached a certain point of anomaly. Eric is a storehouse of interesting information and a practicing acupuncturist who runs his own BBS. He is very with us in the same kinds of studies with an emphasis on Reich's argon. He is going to call Ronnie McWilliams about his radioactive element/argon stimulation experiments. Jerry. Message 10147, December 23, 94, 116. From Joel McLean. 2. Norman Wooten. Subject, 150 turn MRA test. Hi Norm. I tested the MRA which you made per the schematic with 150 turns on primary and secondary, on a single magnet. It checks out at 4.63 time unity. Also, I have observed the analog current meter reading lower with the MRA in the circuit than when it is out. Here's the data, RMS. Secondary output equal 14.3 volts, alternating current at 600 ohms equal 241 milliwatts for a net change in DC current to the amp of 0 mA. Resistive equivalent on the output for 0 mA change is 1300 ohms at 9.75 volts alternating current output, so power equal 52 MW to the MRA. 241 mili watts divided by 52 milliwatts equal 4.63 gain. When the frequency was adjusted so that the output of the MRA was 12 VAC at 600 ohms, the input current to the amp decreased by 10 milliamps. It is not possible to calculate gain because this is an effective output impedance greater than infinity. Supply voltage to the amp was 11.89 volts direct current from a 10 amp regulated supply and did not vary at all. Somehow, the MRA is increasing the impedance of the amp to the direct current supply, possibly reducing the conduction of transistors. Joel. Message 10149, December 23, 94, 118. From, Joel McLean. 2, Bill Beatty. Subject, diodes. Hi Bill tilde we used a bridge rect. But that was so we could get useful work out of the MRA, i.e., driving a motor, a fluorescent camping lantern, etc., but for measurement purposes, ACRMS is fine at sinusoidal output. Tilde Joel. Message 10150, December 23, 94, 140. From, Bill Beatty. 2, all. Subject, Internet MRA. Sir tilde is there a email address to get to one of the original people who are working this device? There are a couple of concerns I feel that need to be addressed. 1. MRA should be NMRA, as what you may be dealing with is nuclear magnetic resonance amplifier. As you are flipping the magnetic fields in the magnetic core you are producing energy, the question is at what cost? The following simple and inexpensive procedures may answer a few questions and raise many more. If possible, introduce a low-level radioactive material close to your device. The radium dial on a watch or any object that glows in the dark when exposed to sunlight, or better yet a small amount of a radioactive element, record radiation levels before and after a 24-HR exposure to device. In case of a glow-in-the-dark element, determine how long it will glow before exposure to device and then after exposure to device. Next, take 2 equal amounts of water, using one as a control, expose the other to device. Have water checked by a chemist for changes, extra electrons or ions, or lack of. Also see if water is being broken down by electrochemical reaction with device. It is my belief your device may have some rather interesting effects at low power levels and some very dangerous effects as size and power are increased. It is possible to upset the balance of matter only so far before things start to happen. Materials may start changing, or in some cases start coming apart in unusual ways. This device may have applications in areas other than free energy which need to be explored and may hold even greater promise. Consider the possibility of reducing or using spent nuclear material or waste as a source of direct energy. Extracting the deadly radiation and turning it into electrical energy. This may also apply to complex chemical chains with high atomic numbers. As has been observed and noted by a number of people who have written about their experience with this device on the internet, they feel that there is a field of influence around this object. Flux fields, draws power from surrounding areas. Message 10151, December 23, 94, 142. From, Bill Beatty. 2, Norman Wooten. Subject, MRA testing. Here's a couple of suggestions off the internet. Do you have measurements on the load and the current sampling resistor values? Damn shame if they were mismarked and never checked. The circuit may be altered by connecting meters to it and throwing off the resonance peak. So, connect everything once and make simultaneous measurements. If you have not done so, you could put the current sample resistor in series with the oscillator output terminal that's grounded. Then you can ground the scope to the same terminal, use one channel to look at the other end of the resistor, and the other to look at the oscillator voltage. A separate instrument would still be needed to look at output voltage. So, any luck with the duplicate versions? Message 10153, December 23, 94, 148. From, Bill Beatty. 2, Jerry Decker, SysOp. Subject, Internet arguments. So far it looks like arguing on the internet is worthwhile. As soon as skeptics hear that actual oscilloscopes are being used, and that the output really is DC, they start asking where to get piezos. Also, the same people who are nasty on the public news groups come around later via private mail wanting more info on parts. Interesting. Message 10156, December 23, 94, 856. From, Norman Wooten. 2, Bill Beatty. Subject, MRA. Bill tilde please relay to John Brock on internet the fact that since I am also experimenting with cold fusion and have been doing so since back in 1987, before Pons and Fleischmann, that I have already seen the correlationship with the transmutation that is occurring in the cold fusion cells that John Bockris down at A&M is most excited about. I have a Mills nickel and potassium carbonate cell running that gets cooler as it runs instead of emitting heat as normal. If the cell is absorbing energy in an endothermic reaction, then the only conclusion is that some sort of transmutation is taking place. It is my intent to couple the MRA effect to the cold fusion effect to determine exactly what you are implying about subatomic activity that we cannot at this time understand, much less detect. There is so much to be learned here that it exactly why Joel and I elected to go internet public domain, so that researchers all over the world could apply what we have only skimmed the surface on. The implications are more far-reaching than any one person can conceive of. Norm. Message 10160, December 23, 94, 11:16. From Joel McLean. 2. All. Subject: Ohms versus Mhos. Last night I left a message for Norm describing a decrease in current to an amplifier as having theoretical greater than infinity impedance for purposes of calculating power gain. That has been bugging me ever since, so I went back to the drawing board. In MRA theory, the phase relationship of harmonics is used to reduce the current flow from the input source. This results in a nonlinear power in power out relationship, or ratio. This is mentioned in the file MRA1ASC here on KeelyNet. This is actually done by tuning the input frequency to the MRA for maximum AC output on its output terminals, then detuning the MRA for the most favorable power gain. Detuning causes powerful harmonics to oppose the flow of input current, while continuing to contribute to the circulating current in the primary coil. This alters the effective impedance, and gives the MRA its gain. So far, so good. But what do we make of it when this effective impedance causes the input power of the amp to decline? The lowest level of input, in theory, is in standby mode, with no load attached, so that in measurement terms, the amp sees a resistor of infinite ohms on its output. Up until now, the signal input from the signal generator to the amp has not been given serious consideration because of its extremely low power, 0.1 MW at the input of the amp. However, this signal biases the transistors in the amp. As the MRA's output power increases, the signal at the output of the signature gen also increases, indicating that the amp's input impedance increases directly with its input and output power. Detuning the MRA causes an exact reversal of this process. It was found that at 3.3 VAC at 600 ohms output from the MRA, the transistors are at only 55% conduction. So, it is not the power from the signal source that directly affects output power, but the phase of the input relative to the reflected phase of the harmonics from the MRA that cause the reduction in input current to the amp. I know that this is hard to visualize without the equipment sitting in front of you, but for those who will eventually build an MRA, this information may be useful. Now, how do we calculate gain when the input current to the amp decreases under the load of the MRA? We have to see the MRA as producing Mhos, the opposite of ohms. Yes, Mhos exist in theory. I'm not making this up. Due to the effects of interphase relationships, the load, MRA, crosses the line from being a load to being a source, and the extent to which it reduces amp power is gain if a corresponding output gain is seen or if the MRA output stays the same while input power decreases. The Mhos from the MRA, by forcing the transistors to conduct below standby levels, are using power which is borrowed from the secondary circuit. The power at the secondary is not free just because the input power to the amp is less than standby. The output power of the MRA also drops, so there is no gain at this point. The reduced conduction below standby crosses a threshold where the harmonic content cuts off its own nose by reducing input power below the level where harmonics are beneficial, i.e., to the point where circulating current in the primary is reduced to a level which causes unity or less gain. Bad Mhos, bad no dessert for you. Your comments are welcome. Joel. Message 10162, December 23, 94, 12:53. From Joel McLean. 2. Bill Beatty. Subject, R, Internet MRA. Hi Bill tilde yes, the MRA draws power from outside of itself. That is because the core is a magnet, and a magnet is in a constant state of collapse, which is why it tries to pull in materials with similar lattice structures, to fill the energy void which was created when it was first magnetized. The MRA allows the magnet to attempt to restore its matter/energy balance, or to demagnetize itself slowly. We are resonating the magnet and it responds by collapsing energy into itself, via the coils which pick up this surplus energy and deliver it to a load. The total energy drawn before the magnet is no longer a magnet will be less than the energy stored in its imbalance. If there was a radioactive reaction, it would have been immediate and very large in the original magnetization process, yet magnetizing is considered to be safe. I think that the MRA would hurt you if you dropped it on your foot, but I'll let that assumption ride without empirical evidence. Tilde Joel. Message 10164, December 23, 94, 15:30. From, Joel McLean. To, Norman Wooten. Subject, MRA energy pump test. Hi Norm tilde I've stated here and in the MRA files that the MRA is an energy absorber, which we have seen evidenced, but which I can now prove. Set up your MRA in 85% mode, and let it warm up. Then, reset the secondary output to half of the maximum output voltage by further detuning the input frequency. Put an aluminum foil shield over it. I'm using an old pyramid made of kite sticks and foil. The output will go down as the shield keeps energy from getting to the MRA. Remove the shield, and the output goes right back up. Because aluminum is non-ferrous, the gain of the MRA can only be affected by the flow of energies external to the device. Tilde Joel. Message 10165, December 23, 94, 1756. From, Bill Beatty. To, all. Subject, another MRA. I've put together an MRA circuit using a 4-speaker magnet and a 1.5 piezo slug. No O/U effects apparent yet. There is so voltage multiplication when it's run at the piezo resonance frequency, but the throughput is only 50% at that point. It's worse at other frequencies. I find no electrical resonance of the magnet/coil, the only resonance is of the piezo. The piezo resonates at 55 kHz alone, 48 kHz when in the circuit. I wonder if something in particular is required to make this circuit go O/U. Maybe location? I hope the device still works when it's sent elsewhere for verification. All the waveforms I've seen so far have almost no harmonics. My numbers come from VPP readings off a scope, not from any DVMs. I'm awaiting some ceramic slab magnets from H&R, so I may still find out more. I wonder if the MRA requires its magnet to be free to acoustically resonate. If the coil is wound so as to dampen the vibration and sound, and if things like electrical tape are used improperly, the magnet won't vibrate. Will this mess things up? Message 10172, December 23, 94, 2051. From, Joel McLean. To, all. Subject, the 300-turn secondary and 60W bulbs. There was an error in message number 10148. The MRA tested today was made by Norm for test, and has a 2-to-1 step-up ratio, i.e., 150 turns on the primary, 300 turns on the secondary. From what I can measure, this is superior to the original 1-to-1 ratio of the first MRA, which I wound to test theory. Makes sense though, because as the magnet inhales energy, the more secondary you have, the more energy will be collected for the load. Also, have noticed that when light bulbs, ordinary 60 watts bulbs, blow, they do so with great vigor and a brighter than normal flash. The filament is exploded off of its posts, and flies around the inside of the bulb with enough force to leave striations on the glass. In the past, I have associated this with an accumulation of virtual particles on the neutral lines of the house, from other experiments. This accumulation causes the lines to superconduct when a light switch is turned on, because the neutral is no longer neutral but at an elevated virtual potential. The effect is the same. Joel. Message 10213, December 26, 1956. From, Joel McLean. 2, Norman Wooten. Subject, retesting for motor drive. Hi Norm. Went back to basics today, since everything had been put away, off the kitchen table, for Christmas. Retested the 2.1 MRA, and adjusted the input frequency to give an even 40 volts alternating current across 600 ohms, and the input from the amp was 20 VAC to the MRA primary. Disconnected the MRA from the amp and connected the amp to the decade box, and found that the equivalent resistance was 430 ohms. So, MRA output equal 40 divided by 600 equal 0.067 amps times 40 equal 2.67 times 0.707 equal 1.89 watts. MRA input equal 20 divided by 430 equal 0.047 amps times 20 equal 0.93 times 0.707 equal 0.66 watts. Gain equal 2.86 times unity. However, when the Pitman motor was connected, the piezo became more conductive, and the power gain dropped to unity or less, so I tried 6 other piezos to find one that would handle the motor load without breaking down. No luck. The first piezo had a lot of miles on it from other tests before we used it to run the motor, and these piezos are fairly new, so it may take a lot of conditioning before they can handle a motor, or maybe an oxide coating has to build up on the surfaces. If the load is too heavy, detuning has no effect. The piezo that we sent to Walt wasn't motor tested, so if he loads it very much, it will probably not make unity. However, under resistive loads such as today's test, it is fine. Joel. Message 10214, December 26, 2303. From, Joel McLean. 2, Norman Wooten. Subject, back in business. Hi Norm. After trying 6 piezos, the 7th was good. It went through the resistive test better than the others, and on the DC motor, gave 3x gain, with 801 mili watts in and 2.44 watts out. The input is AC RMS, and the output is DC. Not sure why the difference with this piezo, but we'll try to find out what is different about it. Joel. Message 10215, December 27, 732. From, Norman Wooten. 2, James Johnson. Subject, MRA. James. Excellent report on the sine wave chopping. See, you are verifying exactly what I have been saying all along about trying to replicate John Keely's work with computer-generated waveforms. It won't work, for you have to have the purest sine wave that is obtainable to achieve the results we are looking for. The MRA circuit is the same effect. You have to use sine wave input to set up the dual resonance required in the piezo and magnet at 3 octaves separation, or you get no cigar. Thanks for the report. I am still looking for the Hammond organ sine wave generator before proceeding any further on the water dissociation. Norm. Message 10216, December 27, 738. From, Norman Wooten. 2, Joel McLean. Subject, MRA, Bill Beatty version. Joel. I set up Bill's MRA yesterday before leaving for San Antone to visit my son and daughter. It burned in from 8 o'clock a.m. till 1 o'clock a.m. this morning, so it is well seasoned now for delivery to Bill. We'll jot down the parameters so he won't have any trouble booting it off for his test. It is a carbon copy of the 12:1 ratio, for it has the 2:1 winding ratio like the last one I delivered to you. Norm. Message 10218, December 27, 919. From, Joel McLean. 2, Norman Wooten. Subject, oxide coating and solder. Hi Norm. Now that the MRA has been conditioned with the new piezo, The effective impedance of the circuit is slightly over 2500 ohms, and the power gain is 14.3, with the motor load. It came up within a half hour of powering it up. Output and input voltages both climbing until the DC out was 15% less than max, while the voltage applied climbed until there was no drop across the MRA. I used the decade box across the power in, and adjusted it until the input voltage was starting to drop, which was at 2500 ohms. It is now tuned and balanced at 33.83 kHz. The only difference with this piezo that is visible is in the method of soldering the leads. I dripped a ball of solder on each side, and there is flux around its edges on the piezo. I then tinned the leads and melted them into the solder balls. I think that this works because it doesn't break through the oxide coating. Reminds me of Bearden's concept, the old wire idea, only works if you don't scrape through to the copper. Joel. Message 10220, December 27, 94, 1504. From, Joel McLean. To, Norman Wooten. Subject, Ultimate Test. Hi Norm. I just did the ultimate test of the MRA, proving that it is over unity even if you assume that the amplifier which feeds it is 100% efficient. I measured actual AC current to the amplifier, both with the MRA connected and disconnected. The difference at 120 volts alternating current is 12 milliamps. This means that 12 milliamps times 120 volts alternating current equal 1.44 watts times 0.707 equal 1.02 watts into the amplifier. The MRA is, at the same time, supplying direct current output power to a motor of 12 volts direct current at 140 milliamps, for 1.68 watts. So, even if you assume that the amplifier is 100% efficient, which it definitely is not, the MRA is still 61% over unity. This is a bottom line number to cut through the haze of power factor questions, and end the discussion of whether it is over unity, so we can determine exactly how much it is over unity. I don't think that anyone will suggest that the Radio Shack amplifier is over unity, so the gain can only be coming from one place, and since it's direct current off the bridge, it is true power. Joel. Message 10221, December 27, 94, 1726. From, Joel McLean. To, Norman Wooten. Subject, Addendum to Ultimate Test. Hi Norm. Went back as you suggested and checked the input from the signature gen to the amp. The output terminals of the signature gen have 1.27 volts alternating current across them, and measuring the drop with a series resistor, there is 0013 W from the signature general. Actually, you can remove the signature gen return line and the MRA will stay in oscillation with no current from the signature gen except a few microamps of leakage current, as I found out as I was connecting the series non-inductive resistor. For all practical purposes, there is no power being added to the circuit from the signature general. Joel. Message 10235, December 28, 94, 1205. From, Bill Beatty. To, Norman Wooten. Subject, MRA measurements. This guy Bob Jewett on internet pointed out a measurement problem which I had not noticed. Voltage measurements across a resistor cannot be done as two measurements referenced to a third point if phase is variable. In some common resonance circuits, the voltage on either end of a resistor could be way out of phase with respect to common, yet the peak and the RMS voltages on the resistor ends would be identical. So if you measure each end separately, you see the same voltage, and assume the current is zero. But if you measure across the resistor, you see a large, real, voltage, and discover the current is large. So, measurements must be done with a floating meter across the resistor, or with a dual trace scope in differential mode and the two probes placed across the resistor. Or you can always move the position of the resistor in the circuit so that one end is the same as the common point of all the test equipment, then measure from the common point to the high side with less chance of mistakes caused by phase. Message 10237, December 28, 94, 1323. From Joel McLean. 2. Norman Wooten. Subject: MRA reduces AC line current. Hi Norm tilde I left the MRA on all night and ran the I/O test again, comparing the AC power into the amp with the DC power out of the MRA under a motor load. The audio amp now draws 3 mA less line current from the 120 volts alternating current input when the MRA is on the output of the amplifier. The motor is running along with 10.6 volts direct current at 140 mA of power from the MRA. The MRA is forcing the amp's transistors out of conduction, which is seen by the line input as a lower load requirement to the power supply of the amp, or basically as a higher resistance to input current. This means that the MRA is producing MOS, which it could be using for its own circulating current, but instead is using to drive down current from the amp. I compared this with the universal resonance curve for series resonance circuits by first changing the input frequency until the MRA was out of resonance, then bringing it to full output, then reducing the gain by increasing the frequency. The MRA, out of resonance, causes a 3 mA increase in line current just by being connected to the amp. As a series resonance circuit, the MRA has theoretical zero impedance, limited to copper loss, at peak resonance, which is its max power output point. Detuning the MRA by increasing the frequency should decrease the input current, which it does. However, at the 65% point of relative resonance, which is where it is now, the resonance curve intersects with the phase angle of applied current from the amp. This is the knee of the input current phase angle rise. The current should continue to rise, but is being forced down by the harmonic content of the MRA at resonance, as seen by the decrease in input current to the amplifier, not just below the non-resonant load of the MRA, but below no load. Joel. Message 10238, December 28, 94, 1412. From Joel McLean. 2. Bill Beatty. Subject: MRA measurements. Hi Bill we have tried both methods of measurement, and the problem which we have is that there is very high voltage multiplication across both elements of the series resonance circuit. We are dealing with typical Qs of over 100, which is normal in a series resonance circuit, but which make a voltage drop measurement meaningless. So, we measure the equivalent load using a precision decade box, or as most recently we measure the delta in input power to the audio amp, which will decrease under the output load of the MRA at 65% of the resonant peak. Phase isn't just variable, it's 180 degrees out relative to the individual components. No matter where you put a resistor in the series resonance circuit, you will measure a drop which is the result of multiplied voltage. But you can't fool a decade box. When you remove the MRA and put the decade box in its place, and set the resistors to give the same delta in applied voltage, you know exactly how much current is being drawn. If you use a current probe, which we have also done, you also see the multiplied voltage, because the pickup of the probe is a coil. I would think that, based upon his question, Bob Jewett is aware of these considerations. His assumption that you will see a high voltage drop is correct, because you are measuring the difference in multiplied voltages. Now if you want to relate this to actual input voltage, divide this drop by the multiplication factor of the circuit, and you will have the voltage which you can use for current measurement, and which agrees exactly with the decade box. You can prove this with any series resonance circuit, it doesn't have to be the MRA. Joel. Message 10242, December 28, 94, 1545. From Norman Wooten. 2. Joel McLean. Subject: MRA. Joel sure sounds like you have been busy nailing this beast down. I built another 2, one for Bill, and will visit later to discuss the other test. Everyone is asking the right questions for which we already have plowed the ground, so have some answers. You know I pinch myself all the time and ask, is this really happening? Verification is the answer to all the questions. Norm. Message 10243, December 28, 94, 1815. From Joel McLean. 2. Bill Beatty. Subject, drop current and decade current. Hi Bill. Here's some numbers taken from actual measurement to help define the primary current drawn by the MRA. Voltage applied from amplifier equal 23.38 volts alternating current. Equivalent resistance measurement equal 500 ohms. Current equal E divided by R equal 0.0468 amperes. Series drop across 2 ohm resistor equal 0.380 volts alternating current. Voltage multiplication equal 4 times input voltage in the series circuit. Note, combined voltages across piezo and primary equal 4 times the voltage applied by the amplifier. If we're going to apply the current derived by the drop to input voltage for power, then it must be the ratio of the input voltage, not the multiplied voltage. Voltage of 0.380 volts alternating current divided by 4 equals 0.095 volts alternating current. Current equals 0.095 volts alternating current divided by 2 ohms equals 0.0475 amperes. Power in either case is equal to 2338 vac times 0.47 equal 1.098 watts. RMS power equal 1098 W times 0.707 equal 0.777 watts. Measured output from the MRA is 18.4 volts direct current times 0.140 equal 2.576 watts. Power gain equal 3.32 times unity. I don't know what else to do, or what other test to perform at this point, so I'll stop here unless someone can suggest something. If reducing AC line current in the previous test wasn't enough, then I guess nothing ever will be for the eternal skeptics on the INET. Joel. Message 10253, December 29, 94, 6:24. From, Norman Wooten. 2, Bill Beatty. Subject, MRA. Bill. After successfully running the MRA on December 12. Joel and I videotaped the original prototype running on his table and driving 2 loads, i.e., light bulbs and DC motors at the same time, so that no one could say that this was RF as we have seen when experimenters run small neon tubes. The video of course has date time stamps on the footage. This is normal and prudent procedures when establishing time and place of invention. I have had so many calls now requesting magnets and piezos that I cannot possibly supply them. I spent about 3 hours on the phone yesterday talking to people across this country re-MRA. The biggest problem that I have encountered is the fact that all who have called have only the original MRA ASC file and do not have the MRA1 ASC and the most important RULE9 ASC. Without the RULE9 ASC they do not have the theory that makes the MRA possible. Copies of the MRA ASC are being sent all over this country to friends and other researchers without the RULE9 ASC. Are you posting the MRA, public A, messages to internet each day so that there is a constant update as to progress? Norm. Message 10254, December 29, 94, 6:36. From, Norman Wooten. 2, Joel McLean. Subject, MRA, power test. Joel. I have been putting a lot of thought into the high power test of the MRA device. Since you have determined that the circuit is creating what we call MOS, and usually this phenomenon is associated with vacuum tubes in operation, and going back to the work of T. Henry Moray with his valve, then I am setting up this 250 watt tube power amp for the ultimate test. Since transistors seem to not be able to take the bucking effect of the first harmonic check in the input current into the circuit, we should use the vacuum tube for this final stage of signal injection into the MRA series resonant primary. The finals tubes then are basically in the series circuit and will survive the punishment brought on by the hammering effect of the first harmonic. These large output tubes will display more of your MOS effect than simple transistors. I still believe, I keep dreaming about it, that the vacuum tube should play a part in the circuit as a coherer of the ZPE into the circuit. Certainly worth trying, for we are at the point where we need to push the piezos at their design power ratings of 50 watts at 150 volts. There will be some serious voltages developed in the series resonant primary, for we have already seen nearly 1000 volts circulating with only 20 volts of primary input. A vacuum tube is the only animal that could survive the punishment in a high voltage circuit like this. Bob Paddock's indestructible transistors won't cut it in this harsh environment. Thoughts and ideas. Norm. Message 10257, December 29, 94, 1022. From, Joel McLean. 2, Bill Beatty. Subject, testing, 1, 2, 3. Hi Bill. You made a suggestion a while back about going into the amplifier output section and measuring current from an isolated point. That was done this morning, measuring both voltage and current into and out of the isolation transformer. It was easy, because the XFMR leads are wire wrapped to pins on top of the PCB. The input to the isolation transformer is consuming 2.4 watts, and the output is measuring 1.9 watts, while the MRA is providing 2.3 watts, which is less than the input to the isolation transformer, but more than the output. Since the secondary of the isolation transformer is part of the voltage multiplied primary of the MRA, its power at 1.9 watts may be overstated, but regardless, the MRA output is above it by 26%, and that is DC, after a bridge rectifier. MRA primary current was decreasing while the secondary output was increasing, but I took a reading rather than wait all day to see exactly where it would go. Increasing power to the MRA, went up to 20 volts direct current out on a 19.1 volts direct current rated motor, increased the ratio to 30%. What this is saying is that the gain of the MRA is high enough so that it doesn't matter whether you measure primary current direct inline across multiplied voltage, it's still over unity. Now I really don't know what to test next. Suggestions. Joel.